Hello.
Let me see. How many people we got? We got 10. Cool. Mario. Hey Mario.
Hey Mario.
And Pumperdad.
Yeah.
And
computational mama.
And computational mama. Hello to everybody. I think we got it on the first try today. I think our audio is good, but
yeah, please let us know.
We don't want to make any assumptions.
Exactly. Is it, especially me, because I think I was mono most of the previous streams, which I wasn't aware. Some people told me that they could only listen to me in the left ear, but we could never figure out because Eliza and our guest can listen to me stereo. But thanks to Tim, yeah, exactly. We figure out. I always thought it was my console or something, a setup for my Mac, so I was always checking that out, and it turned out that it was in OBS. That it was turning my sound into mono, so that's why I could never figure it out. And you could never, like, people that was in this conversation could not listen that. So
I thought it was intentional when I watched, because I watched, you know, obviously I came in for your last stream, but then I also watched it again from the beginning a little bit. And I just I thought it was kind of nice. It was like Eliza in one ear and then ilithya in the
was I also mono? Oh, I never.
I don't know. I know for sure
Maybe.
that I thought that ilithya was like, but I thought maybe I just immediately assumed it was like you had like these two friends on either side of you.
That's
or something.
Funny. Oh, I like that.
That's an interesting idea when we're alone to do this. I like that.
Oh, wait, so does everybody have two green lines right now?
Yeah. Now I'm always checking that before. I only look into the levels of the green, but I didn't realize that each bar meant like left and right, because I would go to the settings and I would see, okay, my mixer, it's stereo, so no.
Cool. Well, awesome. I'm glad.
But I think people says that we're good now. Yeah. Cool.
And so, as everyone may have guessed, we are joined today by lejeunerenard, known also as Sean Zellmer.
Hi.
We're so glad that you're here.
Welcome.
Thanks for having me.
We're so excited to have you and to learn more about iridescent, especially rain marching today.
Yeah.
Hopefully I can live up to the title of iridescent king that you gave me.
You're definitely 100%. You've already surpassed it. Like, I think I told you that the other day because, and that's why I was thinking about how long you've been doing your dailies for. Over 4 years. And most, if not, I feel like, no, not all of them, because you did some like monochrome stuff too, but most of them, that's like over 4 years of iridescence.
Yeah.
Like the official king of iridescence.
Thank you. Yeah.
Iridescence, dare I say? But yeah.
Say that last bit again. What about iridescence?
The god of iridescence.
I doubt that.
Sounds weird, but yeah.
Yeah, I think that's putting a little too much pressure at that point. I'm okay with king.
You can be king now. Yeah.
I can rule over my little domain. I'm good with that.
My audio is low.
Yeah, cool. So, by the way, why don't we start for the people that maybe have no idea who you are?
Sure.
But tell us about yourself. What do you do? Where are you from? Where did you grow up? Do you live in a different city that the city that you grew up? And a little bit like that.
Sure. Yeah. So, as you said, my name is Sean Zellmer. I am a creative technologist, a freelance creative technologist, and that kind of entails all sorts of things, whether it's creating art. Some people see me as motion graphics artist. And I started doing freelance about, 5 years now? So it was basically almost as long as I've been doing dailies. I started in 2016. So yes, you have my Instagram up. I've been posting my dailies every single day on Instagram originally, and now I'm doing it on Twitter and TikTok as well. As far as where I was born in California, in the US, and I've lived both on the East and West Coast. I moved from California into Massachusetts for 4 years, and then back to California, both in Southern and Northern California. But most of my time in California is spent in the Bay Area. And yeah, so I lived there until college, which I came to Illinois for, and now I live here. So still in Illinois. been here, if you count graduating college, it's been about, what, 11 years or so?
Wow.
It's probably the longest I've ever lived anywhere. So,
Oh, yeah, that's a long time.
yep. So
what is there in Illinois that California doesn't have? Because I feel like usually people go the other way, they leave the East Coast for the
Good question.
California.
this is also probably, when people hear I'm from California, but I live in Illinois, that they almost always ask that. Yeah, they're like, what? Why would you do this? I think that each place has its own charms. Maybe it came from just, moving around a decent amount when I was growing up, but like, I kind of learned to appreciate the different things about the different places. So in Illinois, Chicago is really interesting. It just has a lot more history than I feel like, I don't know. There is probably a lot of history in California that I just don't know about, but I don't know, like the Chicago fires, like White City, various things. I think though that probably the biggest reason why I'm still in Illinois is just my community here. Like I have lots of friends. So yeah, it's just like I'm a virtual being in the sense of being a freelance web developer / creative technologist. So like, why not just live wherever I want and can just commute when I need to. I often go to California because most of my family's there. So I still get my California fix every once in a while.
Where in California, by the way? Do you want to say?
Mostly the Bay Area. I did live in Orange County for about 2 years, but Bay Area and the East Bay in Livermore. So.
Okay, cool. Yeah. Well, Chicago is a beautiful city, I must say. I've been in Chicago and I really, really liked it.
Yeah.
I only know that it's called the Windy City and that Oprah used to live there. That's all I know about Chicago.
No,
yeah.
It's great.
It's an interesting place. Windy City, I think that name comes from politicians I've heard. It's actually not about how windy it is, though it is really windy. So
yes, I had heard that too. I remember being very confused when I learned that, and I was like, "Oh, it's not because." I thought it was because there were lots of buildings and like there was like a hardcore downtown core with lots of wind. I don't know. In Montreal, that's how it works. There's a lot of wind in the downtown buildings.
Yeah, totally. I think that where skyscrapers are, there is probably more wind than the rest of the neighborhoods. So, but yeah, it's an interesting place. I feel like I was going to say something else, but I forget now.
You studied in Chicago as well, like uni? And you studied math, I think?
Yeah, math and philosophy.
And philosophy, which is like so good.
Yeah, thank you. Yeah, I think that another common question I get is when I tell people what I majored in, and they're like, how do those connect? But to me, they are very obviously connected. Just because,
the more I learn about math, the more I'm like, wait, in fact, it's just philosophy with, I guess, another like alphabet. That's how I simplify it. But I'm also, I would have loved to study math, but I wasn't mathy in high school.
Yeah, I did not appreciate math probably until truly came into college, because it was just what I was really good at. So it was kind of just natural to me, and I liked it in that respect. It was relatively easy for me. I remember at one point I learned in, I think it was my junior year of high school, that we were doing pre-calculus, and I realized I could program my TI-83, and I was like, well,
the scientific calculators,
yeah. So really old school calculators, like I don't even know what the programming language technically would be called. It's probably like BASIC or something like that.
Really? I remember grabbing the games that you could get for them, but I didn't know how to program them. That's so wild. That's so funny. I forgot about those things.
Super low level. So I just kind of, in the end, I saw all these common problems we would get as tests or assignments, and I would try to program those problems into my calculator so I didn't have to do them. And I at one point felt kind of guilty about it, and so I asked my teacher, I was like, is this okay that I do this? And he said, if you can solve it, then that's okay by me. You clearly know what you're doing. So
that's awesome. Oh, that's cool.
Cool. By the way, I will interrupt a little bit because they said that your sound was a little bit low, Eliza. But how's Sean, by the way? Are both of them low? Because then I can make them
I think
higher.
You can turn me up
But if
on your end.
but that's why I want to listen if Sean and Eliza are the same, because you come from the same end, so you should be always. Sean is fine. Then you have to elevate your
I
gain.
can't turn it up more than I have. It's at max.
Oh, really?
Yeah.
Oh, okay, because I have the both of you in one channel. So if I turn it up, then Sean is going to be even higher. I will turn it a little bit more. Let's see.
Maybe it's just... You want me to... I can, like, move my mic up.
I turn a little bit up, both of you.
I'm also, like, not speaking so loud. I can try and speak louder. Can you guys hear me better now that I'm here?
At least I can.
Okay,
Much better.
Cool.
Okay.
Cool. Yeah, it looks like Mario says it's better too.
Yeah.
Competition.
Sorry, guys.
Okay, cool.
Usually I have a giant hoodie and my mic's, like, right here.
That's a nice place to put it.
Oh, I'm so jealous that you guys study philosophy and math in uni. And that you're naturally good at math. I feel like I would have killed to be naturally good at math, so that I stumbled into it by accident in uni like you did. Because to me, it's just such a funny. It's the language of nature. I don't know if that's true, but that's the way I understand it.
I think so, and I think that's where, like, I feel very fortunate that, like, ultimately having this semi-natural ability, you know, like, was able to, like, I want to create art now that helps people understand mathematics better, because I feel like mathematics is this kind of, like, metaphysical realm, you know, that has all these weird objects inside of it. And if we are just intelligent or clever about how we go about, like presenting that, then people can understand it a lot better, and they'll start seeing the relationships, because, like you said, math is the language of nature. So having the ability to, like, see how math is tied to nature, in this kind of, like, seeing these little patterns, seeing, like, we can look at a lot of things in life, and we'll be like, kind of understand it just naturally. This, like, we're not doing like cognitive processing. We're not saying, like, oh, this is working this way because of this. Instead, we just kind of intuit it. And I think that if I can translate these, you know, very ethereal objects into something that's more in that domain, as I have opted to, there's, like, this language that one of my art friends, David Haskins, uses for his pieces that are all about the sky. He has a piece called Sky Cube, and he talks about bringing the sky to the pictorial plane. And so I see something very similar for mathematics, that, like, I'm taking, like, it's not above you, you know, it's in this, you know, ethereal plane, but, like, bringing it to this part of the gallery, or this part of, like, in the case of a lot of my work, on people's screens, you know, whether it's your iPhone or your computer. So yeah, I want that pictorial plane to be a look, or a portal into mathematics.
And I know you're really into fractal.
Yes, that was probably the main reason I started learning ray marching as a technique.
That's why I want to learn it. I want to make a Julia fractal one day. Yeah.
So I feel like I've not really touched a ton into fractals as I could have. Like, there's Apollonian. I don't even know how to pronounce it, obviously. But yeah.
I think you're right. I think it's Apollonian. Yeah, I think that's it. It's the way I read it in my head when I see it on paper.
Yeah. Apollo-like, or something.
Yeah. Cool. But yeah, you know, you've posted a little bit of fractals, but you stick to like more cubes, and I love how you twist everything around, and like and the
shapes.
ones you've been posting lately with the little holes and things, and just the way everything moves is so satisfying.
Yep. Yeah, I think that's partially why a lot of my followers are not like necessarily very, like, creative coding oriented, is that they just see these kind of, like, very gentle, you know, jelly-like shapes. Blobs are basically how I describe most of the things I create, you know, just like this kind of amorphous thing that just, like, is gelatinous and moving
relaxes
around.
It is relaxing. It's very meditative. I think a lot of creative coding that gets really into 3D shapes and stuff can often either be, like, very meditative, colorful, and relaxing, or else, like, very dark. Always, like, either edge of the spectrum, I find, once you get into the 3D universe. But
Yeah,
Well,
I
it's
guess
like any kind of art, I'd say. So, like, I would say creative coding is like when you go and see in a museum paintings, now it can reflect as well what the artist is like passing through, I would say, like
yeah.
emotionally, like either
For sure.
happiness, something sad, or
Mhm.
when it's a lot of dark, it doesn't necessarily means that it's like depression, but maybe just part of the personality of the person that, you know, enjoys, like, I don't know, maybe dressing in black, or
Mhm.
a lot of like hardcore music. I know
True.
sometimes you can tell a little bit of the personality of the artist, I feel, at least, so by the way that
Mhm.
they depict what they do. So
Mhm. Mhm. Yeah, and it's I think that makes a lot of sense, and especially like even like the description of like either being relaxed or maybe more darker, you know, like intense in flavor. Just because if you think about it, like you're saying, expressing emotion, that if art is is conveying some sort of concept, uh, that like how you feel or what you think about the world, usually that's not going to be like the mundane. It's just going to be something that's
Totally.
more polarized, more to like intensity, and even if that intensity is relaxation and complete like calm or something.
Yeah.
So
No, you're right. That's very true. Why would you be in a neutral zone?
yeah,
Creating art in a neutral zone.
I think the closest thing I can think of is like normcore or something, you know,
Yeah.
like where like it's supposed to be ironic, or and that's still even a concept, you know. But
Yeah.
I definitely think about like the extremes and like how things are pushed in general, partially because I just like weird things, you know, like I think I like things like I'll admit just because they're weird, you know, like so that might
trippy
even be,
things as
yes,
well.
trippy things,
I,
or
I think about that with the colors, like you choose, like
Yeah.
iridescent,
yeah.
and
Well, that was I was gonna ask you what would you what like part aspect or type of like I guess philosophy slash what philosophical idea do you explore the most, you find, in your work? Or I mean, maybe you don't want to put words on it though. I don't know. Some people don't like to put words to their art.
Yeah, I don't think I ever have a problem. I always know that whatever words I put to the art, that's really subjective. You know, that ultimately my viewers interpret it vastly different than I do. You know, like one of my favorite things is getting feedback from other people, and one of the most consistent recently has been my grandmother. That I've now set it up that I text her my dailies because she doesn't know how to use
so
Instagram.
sweet.
Yeah.
That's lovely.
And she has like she doesn't, she's an artist in her own right. She's done poetry and painting throughout all my life, but she doesn't at all, to my knowledge, really understand what I'm doing. She doesn't get that like it's a computer. She's never seen it in person for sure. But yeah, so just like seeing her interpretations of these abstract forms, you know, she pulls all sorts of things from it, and especially since she is kind of creatively oriented, she just kind of like comes up with things that are like not just like, oh, that looks like this, you know, that reminds me of this. It's like sometimes she remarks on the colors and just, yeah. So I guess as far as philosophy of what I bring, certainly the idea of bringing these metaphysical objects into pictorial realm is probably the thing I tell myself the most. I think that sometimes I do, because it's a daily practice, it's really, I see it somewhat more of as a sketchbook. That it's not like something I put a lot of effort into necessarily every time. Sometimes it's like 15 minutes of active work, you know, and other times it's like 6-8 hours, you know. It really depends. But what I think the common themes are definitely trying to generally go for relaxing and or trippy, you know, like as far as the end effect on people. And I think that the relaxing part comes in part from me historically struggling with anxiety, that like it's even like a way of trying to wish it upon myself, and also then give calm to other people.
Yeah.
And I think that like if it can be mathematically oriented, then all the better, because there's a sort of like assurance that I get from mathematics that even though there are lots of ways that it is not as dependable as most people think, I think that at the same time it can still like there's not a consistency in the mathematical sense, but like there to us as humans, like it feels very consistent, and that you can kind of just trust what's going on. But then it also kind of leads into the trippy end of the spectrum, that even if you like see something that like trippy, I would say, is really the phenomenon that people looking at something don't know what is going on. Like it tricks their brain. So like optical illusions, they usually have like implied motion or implied form or something like that. And that when you have that, it feels like a cheat, or it feels like something that is ultimately trying to hoodwink you, trying to get you to believe something that's not real. But when it's backed by mathematics, you know that instead that there is a sort of truth behind it at the same time. So I don't know. It's like, I think that then thinking about like anything that brings you anxiety in the world, you know, like your job, whatever it is that you're worrying about, that there's some comfort knowing that there's this underlying sort of like logic to everything. So it can kind of seem like it's weird, you don't understand it, but that's just your limited capacity of perception, you know?
Oh yeah,
I agree with that. Yeah, me too. It's like, again, for me, it's like doing any kind of art for like one's own mental health. Like for me, sometimes it feels like that when I'm doing creative coding, like maybe I don't paint, but I do this other digital art. And that kind of like takes me to this place that if either like I'm having like anxiety or depressed, it just makes me happy. So try to put it in there. So
yeah, it's true, because when you start to code too, you're also in a place where there are constraints and things make sense, so you can put your ideas safely in a little box and let them dance the way they want to on the screen.
Yeah, you can make things manifest. And like I think the main reason why I like creativity in general is because of creating. Like you're creating something not necessarily out of nothing, but like it's still like an additive force into the world. So yeah,
I love it.
Yeah, cool. By the way, I've been scrolling.
I've
never done this before through all of your Instagram. Meanwhile, you're chatting, and very, very interesting to see. Like
you probably see lots of common themes, or
sometimes you do take black and white, like you leave color for some days, and then suddenly you take iridescent, or suddenly you take maybe not iridescent, but just different colors. Like here you have like red and orange and blue, not really iridescent. Yeah,
it's true. It's interesting because you actually are able to jump around between different color schemes and stuff, but as like a whole, it still also all works together. Like it's like you gently move from color scheme to color scheme if you do shift.
Yeah, I think that like I kind of had these two modes. I have like the mode of like value being like just black and white, you know, like what is the contrast, and that tends to be much more art oriented because that's so easy to trick the brain with. And then color is just, I think that truly I only got into colors as I tried to pursue iridescence, because at least from my recollection, the beginning of my dailies was almost entirely black and white. That at one point I was talking to Reza, and he and I were just getting to know each other, and we talked about like color and how we struggle with it. And I feel like it is so hard, and especially like that if you think about how color is different than black and white, that black and white is one dimension axis, and then color is three. So that means automatically it's going to be at least 3 times more complicated, if not more. So I think that trying to learn more about color theory really is like something on my to-do list to make it more accurate. But ultimately, I think that, I got there because of iridescence, that just trying to simulate light allows me to explore a lot more color, because then I don't have to decide, you know, that I just leave it to light in that sense.
Which is like one color. It's like a non-color. It's just like white, which is amazing.
Right. Yeah. And so like trying to take that property of like being the superposition of different colors to see like how do I differentiate color, like, and a lot of that happens from, and I think we'll talk about this today as we code, but like there's like diffuse, there's specular, there's iridescence, and iridescence itself comes from different things. Like it could be You could be talking about microfacet iridescence, like in opals or in butterfly.
Yeah, that's the one I know the best, I think. That's what I've used in Unity a little bit. But
okay.
Yeah. What other kinds of iridescence are there?
Well, I think that one of the ones that pops out the most for my works is dispersion, which is more the prism effect. So
Oh yeah, okay.
Yeah, so like white light going in and then it being split into that rainbow. So that kind of stuff, you know, like thinking about what happens on the surface of the object and also inside the object, that the more you can incorporate, the better.
I love it. Yeah, I'm into the prism. I kind of feel like the universe is like a prism. But yeah, cool. Okay, shall we pivot to the code in that case, since we're talking about iridescence?
Yeah, sure. Yeah. Let's do that. I was just like hypnotized scrolling.
Like the donut that we have here to start with. This is our pseudo attempt or pseudo successful attempt at faking iridescence. Which we've managed to do a few times in 2D as well, but really we just, I think, mixed colors enough that they looked kind of like shiny and but it's not, we had no lights, so it's
right.
And we were using the color palette from Inigo, which I have no idea if you're using in your iridescence. So
that is probably one of the main things.
Okay. All right. So
I think that when talking about iridescence and us moving forward with this as our base template, I was thinking that I feel like I've talked about in previous streams when I've like interjected, like talk about doing normals or doing different diffuse and other things. So if we get normals, that would maybe be the first step, because that gives us more information about the surface that we're rendering. And then from there, I think the first, as far as iridescence goes, the first natural thing would be to do something very similar to what you're doing here, but using the normals and maybe a dot product with the ray direction to create this kind of like microfacet-esque iridescence.
So normals are, like, in my mind, little arrows that poke off the sides of all 3D objects.
Right.
And then the dot product is like the angle of
two angles, of two vectors. Yeah.
Two vectors. Okay.
Yeah, it's technically a projection of one onto the other, but I basically use it as because I will normalize them so that they have a unit length of 1, which kind of gets rid of the whole the whole like projection part of it, and just makes it solely the cosine of the angle.
Okay. So I feel like I understand where we're going with this.
Yeah. So I figure, should we start like at the bottom around the main function first to explain people what we have right now?
Sure.
So because it might be that there's people watching that maybe they have not done ray marching a lot.
Yeah.
Right.
And they're as well very like basic. So.
Sure.
Are you guys all in the code pen? I don't see anyone's cursor right now.
Yeah.
Yep. I say ilithya.
Yeah, and I see Sean.
Just I see you guys.
Scroll to the bottom.
Here I am. Yeah, here I am. Yeah. Okay, cool. I love code pen for this. It's so fun to see people jump around.
Yeah.
Cool.
So do you want me to explain, or did you want to explain, or?
Well, you were looking at our template earlier and noticed that we had actually created a template with a little tiny bug in it, which was why our original donut had a bit of a dimple in it. We were adding camera over and over again with our angle.
Yeah, I think it was somewhere in this ray direction that ultimately
we actually had a ray step, and the ray step was having the camera position together with the ray direction, which I am sure we took from somewhere, but I couldn't find the resource.
We combined like 3 different.
Yeah, exactly, because we were reading like different. That's what I meant. Like you read these articles about ray marching, and you find like all of these different ways to do it. And when we did this together, we were trying to mix and match what we found from the different places. But exactly, trying to like, but which is the right way, you know? So so go ahead and explain. I think because you're more secure about what you know. As opposed to us, when we did this, we were testing and really grabbing stuff from Jamie Wong, from Char Styles. And,
But I see you here added the Z, the negative Z.
Yeah, I think actually that was from the original.
Yeah,
So,
that was already there.
yeah, and that's really interesting. I don't know if I fully actually understand what that means, what you guys created, and that's part of what I love about all of this, that you can just slap something in and it can be meaningful and beautiful, and you don't need to understand it all the time. So
you can remove that and put like 1, 0, I think it is.
It's funny
normally.
because I was comparing the code earlier and I didn't find the Z in our original one. That's why I wanted to ask you about it.
Okay.
Yeah, it was there. It's just the set. I created it. That's why I remember probably. I just wanted to animate this, because normally we had a -1. Normally it's just a floating number. And in here, when you normalize this, but when we were creating the donut, I wanted to animate and have this back and forth. So that's why I created this set floating value, mix it. Right. And that's why I had it. And that's what was making it come back and forth. But yeah, for now, we don't need this really. So
yeah, of course. Okay.
Yeah, I guess we're not even using that.
Because we could even do that. Now that I'm doing more ray marching, I think you could do it like within when you create your scene of the shape to move it like in the set instead of coming here. So scratch that, I think.
Yeah, that, or you can move the camera itself. It really depends on what you're thinking about is moving. So I tend to, like for camera position, I have the camera moving instead of the object, because it's nice to have the object just at the origin of the scene. So yeah, so maybe I'll just go ahead and go through here. But on line 92, we have the UVs, and that's entails the frag coordinate, which is the coordinate within the fragment shader. In this case, we have X and Y. And you're taking this uniform of the resolution of your screen and you're multiplying it by half, so you're getting half of that, and subtracting it from the frag coordinate. And then what that does is kind of center it, so that 0 is going to end up being in the center of the screen. And then dividing by the resolution makes it so that it's proportional as it goes out. And in this case, you're dividing entirely by the Y of the resolution, probably because that's maybe the more limiting factor, the one that you want to have is like your reference. So yeah, that gives you UV on the screen, and having it centered, like I was saying. And then we move down to the line 94, where we have camera position. And this is your position in 3D space, that right now it's really just like if the object is at the center, that the camera, kind of like my face is just kind of behind the object and looking at the object. So that gives you your position, where you're looking from. And next, then on 96 is ray direction. And this is, you're taking the UV of the screen. And this is a great illustration I see in the article. This is the Jamie.
Jamie Wong. So
yeah,
that's why
I definitely used his article a little bit for some part of my ray marching learning. I don't remember exactly, but yeah. So having the UV gives you this kind of like your screen pixels, and then ideally you want to kind of just look forwards, which, because you're in the Z positive direction, so this is 0, I'm Z positive, that I want to look the opposite direction, so I want to look Z negative. And that's why right now we have this -1 in the Z component, that we're taking the X and the Y to kind of be the way that I, as a single point, like I have 2 eyes, but most 3D cameras only have 1 eye. And so they like are looking from this one perspective, and they have to shoot out in different directions to give a sense of perspective, to just kind of give something different per pixel. So that's why you have the X and the Y components are going to be made up of the pixel position on the screen. So is that making sense so far?
Yeah.
Cool.
I mean, for us, for the people, we hope so too.
Yeah. And I'll try to keep an eye on chat to see if I have to go back.
Yeah.
So then finally, we can ray march, and that's what line 98 is all about. That we're giving it now, with my version of it, we're giving the ray direction as well as the position. And I think previously this cam position was where you had the ray step, and
Yeah.
the ray step was the combination of the ray direction and the camera.
Cool.
So
we send in the camera position and ray direction, and then we go up to, okay, here we are.
Yep, and then we go up to line 59, ray march. So in your case, you're using the ray march function to do the marching and also to give the color. And this is something that lithya and I was talking about before, that I actually tend to split those out, but it's fine to leave them as this way, just because like if it's simple colors, we can do everything inside of the ray marcher, that you'll have this sort of like, if I hit, we can do this color, and maybe we'll modify your code a little bit to do that. But yeah, in the end, you can do them simultaneously. That's fine. But yeah, so in the end, we start off from a current distance of 0, saying like current distance meaning how far am I from the object that we're trying to render. And then secondarily, you have on line 63, you have ray depth, which is like how far am I from the camera as the ray is shooting out through each one of these pixels. You want to keep track of how far you've actually gone, and that gives you information about where you are in 3D space. So yeah, then you have a background color and you have a gradient for that background color. But then the main chunk of it all is the ray marching steps. And so in this case, you have a constant, I'm pretty sure. Yeah, constant for the max number of steps, because you want to make sure that eventually you give up on your process of ray marching.
I'm gonna bring them down.
Say it again.
I'm gonna bring the constants down closer to the ray march, so that they're closer together to be readable.
Yeah. So yeah, you start basically at the camera, and then the whole process of ray marching I liken to being a bat in a cave. That bats are like effectively blind, right? And they use, like, they're not actually blind.
Yeah, they're little infrared sensors, no?
I think they just use sonar. Like they.
Oh, that's what I meant. Sorry.
Yeah.
My bad.
Okay. I think there are animals that have infrared sensors, so that would be pretty cool. And that actually, that is probably what is most likely to show up in like electronics, you know, like robots or something. Like I have, you can maybe just barely see. I mean, on stream, I'm sure it's like not even. Yeah, it's probably not even visible. But I have a Roomba, and that uses infrared, basically in a pseudo.
Is it zipping around your room right now?
No, thankfully not. That'd be very loud. It just happens to be in my frame. I can see that it's in the corner, just because that's where I put it, I guess.
Funny.
So yeah, that it uses infrared to like look around a little bit. It's especially to find its base station. But yeah, LiDAR bats is a good way to put it. Cool. Yeah. So that being the case, if we're sending a bat for each one of our pixels, that it's going in its direction, and that's all it knows. It just wants to basically head in that direction and land safely on the wall or whatever the object is in the scene. So to do so, since it has this sonar, which is really just tells you, imagine that's more simplistic than real life bat sonar, but that we say it just gives us a minimum distance from anything, so that when I put out my little squeak, I get a certain amount of time before it bounces back to me.
Cool.
Yeah. So in that case, that's what our scene is. That's what a signed distance field or function is all about, that it just gives you the minimum distance to your scene or your object. And so in this case, we give it the position, the starting position, and then we add on our distance that our ray has traveled. And how we do that is by the ray depth multiplied by the direction, so that as we're like pointed in whatever direction, there's just like, if you multiply a vector by a scalar, you're just kind of slowly, you know, adjusting the size or magnitude of it.
Cool.
So yeah, once we do that, it gives us a current distance from the scene. That's kind of the promise of what an SDF is. And with that, then we know that's a safe distance to move forwards before we hit something, because we're blind. That's all we know. We just know our direction and how far we can go. So we just go ahead and then add that to our depth, that we know now for sure that we can move that next time. And then in your case, you start doing color. manipulation. You have palettes, which you're doing it based on things like the ray depth. That's kind of like your lookup into the color palette is half of the depth so far. And I also, by the way, modified this coloring. That's why it doesn't quite look, I feel like, how you guys had it originally.
It's fine.
Yeah.
Don't worry. Don't worry.
Don't worry about it.
Yeah. I was very much fixated on the bug instead of the aesthetics. So, but yeah, so we can talk eventually a little bit more about these color palettes. But in the end, you create a shape color, and whether or not you return that is whether or not you've hit inside this epsilon, which that's very mathematical. That's I actually first learned about epsilons from a more rigorous definition of a limit. I think it's a Cauchy limit or something. It's like been a decade since I learned this, but ultimately a way of thinking about limits is like what's the evaluation of a function as it gets really close to a value, and as it gets really close, the key to being rigorous about that is this epsilon. This, in the case of the mathematics, is an arbitrarily small epsilon, but in our case, we can be practical. We can say like, I'm a bat. I know that if something is within half a centimeter or something, I know I could just put out my claw and consider myself on the wall. So
I love this analogy of the bat. Makes me happy. Yeah.
I feel like it's been fairly useful for people to understand.
Right march.
Yeah, ray marching. Yeah.
You grab cool. Okay.
So yeah, that if you're less than that distance, the last time you checked with your sonar ping and you're like, I'm within this small amount of distance, then you've hit the object. And that's where you're returning the shape color instead of the background color, because if you then on line 85, if you get down to where the depth is greater than your maximum distance that you want to go, which is one of the two ways that you can kind of fail out of finding the object, that you either say, I've gone clearly too far, even if I haven't done all my steps, that as you're going clearly missing the object, that you're going to end up never really having a good distance. In fact, as you pass the object, you're going to have a greater distance with every step. So instead of, does that make sense? Like you're kind of just, in some ways, actually, this is a mixing of analogies, but it's kind of like ambulances as they go to and from you, that you're kind of
the
like
way that the sound shifts or whatever.
Yeah, the Doppler effect, I think is what it's called. It's not exactly that, but there's a sort of indication that when the ambulance has gone past like you, that it starts being lower pitched. And in this case, the lower pitch is really just us seeing that we're further and further away from the object as we go.
Well, it's the same when we see birds flying, right? So you see them around when they're like, I guess, in this phase with ray march, you were saying like the bats, but if they go too far, you stop seeing them. It becomes a dot and then it's nothing. So even when they are still existing in the sky, flying somewhere, but you cannot have that view.
Right. Yeah, that because of perspective, we see them being small as they're approaching us, and then they get bigger, and then they get smaller as they go away from us again. Yeah. So very similar in this case. So yeah, if we've gone too far, we say the background color. And then ultimately, if we get outside of this this for loop, we know that we've done all the max steps that we wanted to do, and that means we didn't hit anything, because we would have hit something if then we would have returned on line 84. But if we get to 88, we know we haven't hit anything, so we again do the background color. Sound good?
Yeah.
Okay. So
I mean, if there are questions for the people that is watching and it's on the chat, you can always ask us questions. I mean, so far
people are into the back.
Yeah, exactly.
Finding you very clear.
So I think
we're doing well. And sharing resources about color palette, palette.
Thanks, Lionel. Yeah, we will check that later when we get into it.
So once you've got your object floating around in space and you figured out where you are and stuff, is the next thing to do to grab normals, or do you bring in lights? Like, where does one go from here?
Yeah. So When I do it separately, I basically just return back the information about what I hit and where it is. In this case, we have that readily available because it's inside of the for loop.
Yeah.
So what we can do is maybe what we'll do as a modification is that we'll move your color underneath the if statement of whether or not we've hit the object, because we don't want to do any calculations we don't have to. And if you're going through the for loop, and by the way, I'm not like a GPU expert, that GPUs are very different than most programming. And it does all these crazy tricks about like, it will calculate basically all possibilities sometimes, and then only show the ones that worked.
Okay.
So I don't know exactly, but taking at least the what I know from other programming, it's probably better to only do the calculations after you've checked that it's inside. So
this whole part here, you want to move it outside the for loop completely?
Well, we can keep it within the for loop. Just for, it's kind of nice to think about it as like it's hit. Now we're doing this code.
Okay.
But maybe even what we can do is I'll just I'm gonna, below our array marching, I'm gonna add another function, and I'm gonna call it shade, I guess.
Yeah.
And so why don't we give it a position, maybe a ray direction. I think we've been called radar. Yeah.
Yes.
Gotcha. And then maybe the ray depth. And we can modify this as we progress, but. All right. So I'm going to copy this over. Oh. I normally write in Vim. So I wasn't
you
sure.
were saying.
I find Vim very tricky.
Yeah.
I think if you don't do it every day, for me, it's like a minefield. I get stuck in the thing and then I can't escape, and yeah.
Yeah, so you'll actually also notice that if, I don't know how real time, I'm actually watching the stream right now. Yeah, when I type FP, that's how I get out of insert mode, where you're like actually actively typing. And but because it's not that customizable within CodePen, that's why you'll see me like move around weirdly. That's the muscle memory going.
No worries. Yeah,
it's fine.
So okay, so I've moved that out, and what I'm going to do is I'm just going to replace where we normally return the color. I'm just going to put it into a function, so at least, even though it's still inside of the for loop, it's going to be in its own function. So we just think about this is all of our colors, because
cool.
we'll ultimately say we've hit the object. Now let's just compute what it looks like. So I'm then going to pass the position, which is going to be the calculated position. Right, so that's position, and then again the ray direction, and that will be important when we get into iridescence. Ray depth, I think that was everything, right?
Yeah, you had 3 variables.
And not seeing anything, so there must be an error.
We have an error because
shade. Oh, I have to define the function beforehand, I think.
I was going to ask, yeah, I've never. Can you return a function with stuff in it?
I'm going to do a little trick, maybe, so people can learn about it. But actually, if I go down, if I copy this, the arguments and the input for this, and I just say, I just put in that as a line. I'm effectively,
that's a trick.
Yeah. It just lets the compiler know what the shape of the function is, and then it can hoist it from below up. So it's kind of like in C or in C++, where you'll have like usually a header file that kind of defines the shape of everything, and then the actual like C++ or C file like contains all of the actual code.
Or in JavaScript when you use let I would assume.
Yeah.
So
that's partially,
okay.
I think, even why I did that instinctively is because I mostly program in JavaScript besides
Okay.
GLSL. So yeah, it just kind of like, I just assumed it was going to hoist it.
Yeah, interesting. I had no idea because I know GLSL is very strict when it comes to you cannot like do stuff that do a function after declare it after you are actually trying to use it.
Yeah, totally. Yeah, I think that part of that is because it's being compiled, from what I understand, that usually the driver for your graphics card will be doing a compilation step. And that's even where there's a little bit of lag that that when you're loading, you may even notice if you're like really nitty gritty as a web developer, you'll see like all the assets have loaded and then it will just like pause at the creating the shader. And I believe that's why, is because it's actually doing real-time compiling. So
crazy. I did not know we could do that. That's so neat. Okay.
Yeah.
Cool.
Yeah. So now we've kind of split out our little color. And so if we go down to shade on 85, we can start manipulating things. I think maybe first step, like I was saying, was doing normals.
Can you explain why would we need a normal? Yeah. What would we need it at this point if we already have like our shape or done
like bat analogy?
Yeah. So as far as the bat analogy, we've kind of done our bat part. We've now landed on the surface of the object, and now we put our cause in, and now if we're gonna really try to overextend it, we're like gonna say the texture of it, which is really what we mean is the color of it.
Okay.
The texture would actually normally, as far as creating a visual representation, we would want to do the texture inside the SDF, or you can do certain cheats with normals to create a faux texture on the object. But as why we want normals, what that tells us is that we've kind of landed, we have this 1 pixel, which is what each bat is. We've landed on the object. All we know is where that is in 3D space. You know, like we know relatively to where it is to the camera. That's what our ray depth function is. We know the direction that we were looking when we did it. We know then the position now is like the position in all 3D space. So with that, we want to then get more information, because if you just know where it is in 3D space, you don't know like what direction that face is pointing. I guess really that's the biggest thing. That's why normals is the next thing, is because what normals tells you is how the face is pointing. So when you see these arrows, like Eliza was talking about coming out of a 3D object and most 3D software, that is just saying like this face right here, which is usually some sort of triangle, that it's pointing in this direction, and that can be doubly important. That it's certainly important for lighting, but it also can be important for whether or not it's rendered in normal triangle-based rendering. In this case, we don't care because we don't have triangles, but for us, it's going to be entirely just about the aesthetic, like what does it look like as far as shading goes. Does that make sense?
Yeah.
Okay. And I think that maybe it'll make a little bit more sense once we start writing the function for the normal.
Yeah.
Cool.
Yeah, cool.
Yeah. Talking about triangle normals is reminding me of all the times I've tried to unwrap normals on a sphere in Blender to get everything to work right in Unity. It's a bit of a headache. I'm excited to do this type of normals.
Yeah.
Awesome.
Yeah, this is a concept that to me it has taken me quite some like time to digest, like normals. I've read articles about it, like try to use it, but still like I don't know why in my head it's so hard to grasp.
I think it's like one of those, for me, it's one of those words that gets, you're having your Vim moment.
Yeah.
No, it's totally fine. No, but yeah, normals and UVs, and like I remember getting into shaders and reading and being super overwhelmed with all the different words and what they meant and directions, things pointing all over the place. And so, yeah, I think normals, the way that it clicked for me, Alicia, was just thinking of like, what if light bounced off a 3D object? Where would it be pointing? And then I was like, okay, well, then that'll be like the arrow of the normal, maybe. But I don't know if I'm totally right about that. But
like pointing, so that means that you can achieve shadows too.
Yeah.
Yes.
Ah.
Yeah. So
okay.
we're going to be adding shadows. That doing normals, one of the first things we're going to want to do is called the 𝗏𝗏𝗀𝗀𝗀 shading, which is really just a fancy way of saying like
Lambert.
how, Lambert, or like kind of diffuse shading, like how much light generally is this object reflecting given a light. So yeah.
Okay, cool.
Yeah, and then as far as the term normal, I think it comes from mathematics and or physics. I don't really know which one first, but it just, for me, it was natural because I was thinking about, for example, in physics, there's like equations for how friction works, and it depends on what direction the surface is facing versus, you know, the weight on top of it. So that was always called normals. And I think maybe the word comes from normalizing. It's because
that's also where I used to get confused, because I was like, are we normalizing? Are normals normalized? I didn't understand.
Yeah, true. Because it's...
So they are very much normalized, and normalize, you know, makes it into a unit vector. And a unit vector is nice because certain mathematics, it doesn't care about the length of it anymore. It's like multiplying by 1 in most math. So for us, we want it to be normalized for that reason. And man, I'm brain farting. I think I'll drink some
No
coffee,
problem.
Cool.
Yeah, no, I like this. It's a good training to get these normals and normalize terms back again.
Yeah.
So.
Yeah, you need to like keep exposing yourself to the word. It'll sink in.
Exactly.
Okay, so our general process of what we're going to be doing is we're going to be taking now this fact that we know where we are in space, and we're going to do a pseudo gradient, like it's kind of an approximation for a gradient, which is a gradient is also like a fancy word for normal for the most part, but it kind of has maybe more of an inferring of like a gradient is really like the derivative in 3D space.
Cool.
So what a derivative is very much related to a normal, that it tells you like a derivative is roughly the slope of an object, whether it's a 2D curve or if it's a 3D object. And so what that really means is just how is it changing at this moment if you think of it as a function. So what we're going to do is we're going to do an approximation of that, which is to say we're going to look a little bit to the left and a little bit to the right. We're going to look a little bit up and a little bit down and a little bit in and a little bit out. And when we do this, we're going to get the distances from the surface using our SDF. And then we effectively average them, I believe, from one another. So when you do that, you're getting kind of like, how is it changing as it moves from here to there? And that will give you, because you then normalize these differences, you effectively get this kind of like vector that's pointing out at the object.
Okay, cool.
Can I ask a question before we continue?
Sure.
Because when we were doing ray marching a while back with Alicia, we would copy paste from Inigo's bank of like shapes, and some of his shape functions had this prefix to the vec3 for example. You put an in, and some of them didn't, and we were trying to figure out why.
Yeah, I was about to ask that exactly. Because when I grade shaders, I don't grade this in, but I see it when I grab from somebody else. So I wonder what it is.
And like, why is it there sometimes, but not all the time? So I figure it means that you're receiving a parameter from somewhere, like it's coming in. But or you're inserting.
Yeah, I think that either one of those makes sense. Ultimately, we have a bunch of arguments going into our function, and in a much more explicit language like GLSL, that isn't as forgiving as JavaScript, where it just lets you put in whatever you want. That we're effectively, by saying vec3, we're saying the type of the argument, and then because GLSL is kind of, I don't think it really has references. If it does, somebody can correct me, but like effectively the in or out or in out is also an option. You can do it as like one word. That that would kind of describe as like a reference that usually the out is saying I want to pass whatever I assign to this variable outside of the scope of the function. The in is saying I only want it to be copied over inside, and it,
okay.
yeah.
It
So
doesn't
like,
so you could totally not use that. Like you say, it's optional. You could not, or just be a little bit more specific so the person knows that that vector is only gonna be used kind of inside.
Right.
All right.
So like right now, I just, even though we're not really doing anything inside of our normal function, I went and I removed the ends, and it works perfectly fine.
Okay, cool.
So
is it a question of being more specific in your code?
Yeah, I guess so.
Do something. Okay.
Yeah, I mean, it probably doesn't do it. I think it is implied in without anything assigned, because that's the most common use case, or at least in my experience. But it is kind of more verbose versus like, if I say in out, now suddenly because the sort of in/outness of the argument is important, it can affect things. Like I could say, posts is equal to, I don't know, I'm going to just make it 1 or something. I don't know if this will actually change anything, but yeah, I don't think it will, because we're not calling this function. But if we did, it would actually modify the position. So maybe if I said, here's the normal, get normal, and I'm giving it its post, and then the ray depth. I believe now, I guess not.
Are we using?
But you're not using it. You're not using nor.
Well, shouldn't it be used right here?
But you're just defining it, right? So.
Right. Well, it's outputting this, so I don't expect the normal my fake normal to actually change the shape. I was more looking for the position to end up changing.
Okay.
The reason why is because we're not even using in the color. So.
That's what I meant.
That's what I meant.
Yeah, me too. Me too. You only
right.
define it, but you're not like really using it. So.
Yeah. Okay. Yeah, you guys are right. So then why don't we try do something inside there?
Or pose?
No, because nor is a vec3.
Okay.
Oh, yeah, I see.
Okay.
That's because
I thought that you were going to use the nor variable.
This has to be a float, I think, but then you could use nor as brightness.
Yeah, I could use it as brightness. I'm also going to change the palette function.
Okay, it's dark.
It's so dark now.
Very dark.
So I now have created the palette. I believe that T should be a vec3, but I think it's also not compiling correctly.
I thought that T was a float.
It can be a float. It can also be a vec3, because it's just, you can like basically push it based on each component if you really wanted to.
Oh, cool. Right. Okay. Is it because I put nor that it broke?
Yeah, it's kind of broke at the moment.
It was black for me before. It was still
working.
Working.
For me too.
Okay, wait. Now it's just broken. What else did we change?
I haven't touched the code.
Maybe it's I touched the palette, so maybe that's what it is. I'm going to change there we go. Okay.
Oh, it's so red now.
Yeah.
Cool.
So I think this is with it being modified, that the position is put to 1, which turns out to be red. So then if I go ahead and comment out our call to get normal, now you'll see the position showed as this weird.
Yeah.
Okay.
Does that make sense? So
let me get this. When you were defining this vec3 nor, you don't actually have to use nor by itself, because just by creating it in here is already affecting the position and the rate of being like receiving this normal without actually using it.
Yeah, so it's not being affected by the normal, because the normal is that nor vec3 that's at the output, the return of the get normal function. But I was showing that there can be side effects by saying in out inside of the function itself. So by using position now as our index into the cosine palette that we have, because we were putting it into the get normal function, which we're not doing right now. Like this is like, we're not using get normal at all right now. But as we go down and I delete or use now get normal, what is happening is that the position vector is being put in into the first argument of the get normal function, and then that is coming in, but it's coming in with the qualifier that it's both available inside the function, and whatever you do to it inside that function will now be changed outside the function from where it came from. So that's what the out part of it is, that theoretically we could just call it only out, and it will, whatever we do on the inside of our function will just change what this variable means outside the function.
And if you remove the out and just leave it in as you had it before, then it's not going to be red, I assume? Or...
Yeah, it will go back to that default state because we're no longer modifying the position.
Oh my God, thank you so much. I think I finally get it.
Yeah, of course.
Wow. Okay.
Cool. I've always wondered about that.
Yeah, me too. And honestly, when I get the functions from Inigo, sometimes I remove it because since I didn't understand, sometimes I don't like to put code I don't understand. So then I will just remove it because I was like, I don't know what this is. I don't see it doing anything. So for me, it was like, okay, just, But I didn't consider to Google it honestly either. So, So thankful
I think I tried
that
to Google it once, but it's hard to Google the word in and find anything. Like it took you one to look up.
It's always about knowing like what is it called as a concept, you know, because that will usually get you much closer. But when you don't know what it does, you don't know what the concept is called.
By the way, somebody in the chat asked if the cross product of a UV can give us the normal.
Right. Yeah. So I was looking at that and I was trying to think about it. I guess the assumption that they're asking is crossing the UV with maybe the position or maybe the ray direction. I think that either one, like the cross product, what it gives you is effectively a vector that is orthogonal, meaning like it's at a right angle to the other two vectors that you're cross producting. So UV in our case is a two-dimensional vector. So assuming some sort of like 3D, maybe even the -1 that we were talking about before, that's effectively the same as the ray direction. So I guess I don't know exactly what they would be asking for. So PPS.
You have to be more specific. PPS 7501 if you want an answer.
I was trying to like think through the process in my head and see if I came to the same conclusion. But
cool. No, but this that you explained, wow. Blows my mind. Okay.
Yeah, I like teaching. I've definitely thought about being a math teacher. So
you definitely can.
Yeah.
By the way, one last question regarding that.
Sure.
If you would not have in and you removed it, what's the default? Is it in? Is it out? Is it in, out?
Is it? Yeah.
Is in?
So right now, yep.
The default. Okay.
Right now I removed it. You see it's still calling the get normal. And before when we had in, out, it was modifying position and it is no longer. So
okay.
You can kind of infer from that the only option then is that it's just taking the value inside and doing something with it. So
cool.
All right.
Awesome. Thank you for that detour.
Yeah. Perfect. This is the kind of stuff that I was dying for, you know, because when we do a long ray march, Eliza and I think we're both starring, and some of these questions just
try and dream up what it could mean, but in the end, like you don't, like you're saying, if you don't know what they're doing, it's hard to find the right keyword to look at.
Right. Yeah. So I pretty much expected that we would be talking a lot about the mechanics of ray marching, and I think it's important to understanding, especially getting into like if we ever do get to dispersion, which I don't know at the time, but like we can get at least that microfacet iridescence, and ultimately that, especially with the dispersion simulation, you're effectively ray marching again inside of the object because that's what light's doing.
Cool.
So I think it's very important to know all of these concepts because I need to like stumble my way through all this in order to get to the point that I understood them roughly. So yeah, I want you guys, because I know like especially ilithya, that you've been doing a lot of ray marching recently, and I know that if
I was practicing so not be completely fully lost because I haven't done ray marching in a while, so I was reading.
So I wanted to give this tool set to you and to anybody who's watching, so that they can,
thank you. It is great, because honestly it is like this for every person, I suppose, with any tool. Now the more you learn about how each like tiny button works, in whether if you're using like, I don't know, and I go back always with Photoshop, like if you learn exactly what every button in Photoshop is, like you can create way more stuff than rather if you only know two. Right. So with the shaders it's the same, like with Raymarch, the more like details that we learn, the more I feel that the more creations we will manage to do, not as limited. So
because then you can fine-tune things better.
Exactly. So
okay, so we have our normal function.
Yes, so we have our norm now, and we're going to actually now define it. So like I was talking about, we kind of like walk one side to the other, and what that looks like is we're going to do, I think, the more verbose version that's maybe not quite as performant, but it will be good. We'll have our scene, and if I remember correctly, we have just a position for that. I'm going to go ahead and put that in for each one of these components. And why I'm doing that is that we're ultimately looking for the differences in the distance to the object as we move a little bit from the right or the left.
Okay.
So in the end, I'm going to actually do this twice. Let me double check that I'm doing this correctly. Yes. I have my code for my dailies on my side. So.
Cool.
Yes. Okay. Maybe we can even do something like this, that when we're talking about moving to the left or the right, we're usually talking about doing it in, again, another small increment that we call epsilon. And a little trick, and I think in the Jamie Wong, maybe in both actually tutorials that you guys sent me, that the epsilon, it can be a three-dimensional vector, it can be whatever. You just minimum maybe need two, because effectively what you're saying is I want a small number, which is what this 0.001 is, and you also would then want 0, because you're going to change when you're stepping to the left or to the right. It's only going to be in one direction. And how we do that is that we're going to say, make sure I get the right sign on this, but we're going to say epsilon, we're going to say for the x direction, so x is our small value, and then I can just copy in, even though the epsilon itself is a 2D vector, you can do swizzling, which is this point, like x and y's, that you can add on new dimensions, even from the original variable that you're swizzling, by just repeating certain dimensions.
Okay.
That makes sense?
But why are we repeating? Sorry, you have to go back.
That right now, this is where in epsilon we have the value that we care about for pushing something to the left or right or up or down. That's what the small value is right there. And so we want that to be in the x position right now. And that's why it's confusing, because we're using x to talk about it. And maybe we can even do something like this, that we say like R's and B's, just to kind of, so we're not using the same term. But
wouldn't it be G?
Yeah, you're right.
I make that mistake a lot too. I always go B, and I'm like, wait, what?
I always have to say to myself RGB, you know. Yeah. So, and that was why it was compiling incorrectly. So, so with this, what we're saying is that we want to get only the x component, and then we're converting our epsilon into a 3D vector. Effectively, what we've done here is something like this. We're going to say, if I wrote it out, be this.
Yeah.
Oh, okay. Thank you. Okay, now I get it completely. Yeah, cool. Yeah, because I've been reading about this sizzling as well before, but it was as well foggy in my brain. Now I get it. Okay.
Also especially unique to shaders in general that I don't think most other languages have anything remotely like
yeah,
that. So.
that you can transform it, which is pretty cool actually.
Yep, it's very important for 3D graphics since we're using so many vectors and you know matrices, etc. So, man, every time that FP. So now what I'm doing is I'm going to offset. I want to kind of, like I was saying, I want to go to the left and I want to go to the right a little bit. And when I do so, that is going to, like you're getting a little sample over here. It's like our little bat has hit the wall and now he's going to say, I'm going to do my sonar just a little bit to the side. And if it's like, it could be also negative, like it could be, and that's fine because in math, you just don't care as long as the algorithm doesn't need to be signed. So if it's negative, it's just going to kind of adjust for that in its average. But you're going to say, oh, what's my distance over here? Okay, I got this much. And what's my distance over here to the other side? Oh, it's this much. So then I'll take some sort of average and that will kind of be this like plane almost that we're creating.
Cool.
Gives us a sense of direction. So if I do that 2 more times, and now I'm going to change what,
different, right?
Yeah, you swizzle different. So I feel like that should be like a song.
Yeah, but by the way, I was looking at the tutorial for Michael or Michael. And yeah, that's exactly how he calculates the normal. Kind of like what you're like doing.
This is very common. And I think I originally learned this from lejeunerenard. So
okay.
Just like this kind of idea. I forget what he called it. It's like center difference or something like that. And there are lots of different ways you can do this. One optimization is that you kind of don't need to look always to the left and to the right. You could always kind of like just look in one direction and then look at the distance where you currently are at, assuming that it's roughly even. And that's just kind of like a demo scene type hack that you want to have both smaller source file, but also more performant. So you kind of forsake, you know, this is an approximation. So we're going to forsake accuracy with just the hope of getting something that's faster. So, all right. So I think that is the entirety of how we define this. Right now, we're not really using it. So why don't we use it?
Yeah. Exciting.
So now,
wait a second. Now I'm a little bit confused because where you entered the NOR, shouldn't
Normally
that be a floating number?
That's what he was saying before, though. We can also put a vector in there.
Yeah.
Oh so my God, it never occurred to me to try something different.
Yeah.
But why and how? How did you come up, like, you know, with the realization that you can do a vector and?
Sure. So if we look at the palette function, which is on line 14, that in the end the t is just being multiplied.
Oh, it says there vector actually.
Well, I changed that part. It did say.
You changed it. Okay.
Yeah.
Okay. I was like, oh, it said vector now.
Yep.
Okay.
And that was where we were trying to do the whole position thing and have it show up. Why we got an error. That was because I had changed it there, and then I think somebody, maybe Eliza, changed it how we called it. So.
Okay. Oh, but now I get it. It was just in my head because I didn't see that you had changed here the vector. So in my mind, it was like, oh, the color palette has a float in the beginning, so how on earth? But okay, so you change it, so of course then you can apply the vector.
Yep.
But I'm like curious and slightly entranced by the shapes that the normals are tracing on the donut now.
Like a flower, kind of.
What's happening there? Yeah, it's so interesting. I feel like it's traversed into like the 4th dimension now.
Yeah. I am not 100% sure I can accurately say what is going on here. I can say that when you see something similar, you know that it's the same normal of sorts. So like, if you're seeing the red band is the center, right? So it's like when either the donut's facing head on right here, here's the edge of the donut, that you can see it right there, and that's the normal is pointing straight at the camera. And so what would that be?
Cool. Okay.
Yeah.
And
that's
interesting. So funny.
Yeah, maybe we can try something really quick where we just define the color as the normal, and that might make it a little less opaque.
Okay.
So this is what you normally see with
Ooh.
Yeah.
right?
Okay.
Yeah.
Yeah, this makes
is
it more familiar. Yeah.
Slowly iridescent.
Yes.
Oh,
Cool.
I'm so happy.
Cool.
By the way,
So,
I was gonna comment at the top the 3 axes
oh yeah,
for
please do.
people to look at this code, because when you were like just getting the normal and you created this vector 3 with like the 3
Yeah.
a vector 3 and not a vector 2 is just because you want to have the 3 axes normalized, so
Right,
not only
yeah.
2. So
Oh, right. Yeah.
Yep.
because it could have been like a vector 2. I don't know, for somebody who's watching that, why didn't you just normalize like a vector 2? So
Yeah,
you know,
totally. I think that's good.
Wild.
Okay.
Yeah.
So now you can kind of see where like, so as we were saying, RGB, right? So that's X, Y, Z is the equivalent. That now you can kind of see that when a face is pointed straight at the camera, it's very blue. And that's because the Z is towards the camera. And then R is going to be like mostly to the side, or red is going to be mostly to the side, and green is going to be mostly up. So you can kind of see that on the object, that like in the circle, at the very center, it's green at the very bottom because that's pointing straight up. And yeah.
My mind is
So cool.
exploding right now with all this new knowledge. Finally
I
understand.
find it interesting too that we have like dark shadows even though we have no lights.
Right.
Dark shadows?
Yeah.
What do you mean? Where?
Well,
Okay.
like there's black, there's shadow in there. But
Yeah,
we don't have
so-
like, dark, do we? No, we don't.
No, we don't.
No.
I think it's if I'm not 100% sure about this, but I think it's because that's where everything is either near zero or
Right.
towards negative. So
Right.
I wonder if that's almost like equivalent to a light being in like the 111 position almost. You know,
Cool.
I'm not 100% sure about that, but yeah. So that's our normal. And I think that next we should move into Lambert or Lambertian, and maybe just even calling it something like diffuse, because diffuse lighting is really just
What is Lambert, by the way? Because for me, it just rings a bell because of 3S. When I use 3S, it's this mesh
Right.
Lambert material. So it's on my brain. So
right.
and it's one
yeah.
of the performance materials in 3S, but I really don't know why it's called Lambert. So
Yeah. So
It's like the guy who invented the lighting technique, I think.
ah, okay,
well,
okay,
it's
okay.
probably just named after some French
Okay,
guy.
okay.
So there's a lot of
It's
mathematics.
really
I feel like,
Lambert.
yeah, probably. So yeah, I feel like a lot of mathematics was invented by French mathematicians in general. Maybe besides Euler, you know. But yeah, so diffuse, like what Lambertian gives us is that when we were talking before about like what does light do, and part of my vision for creating dailies, that we can think of like here's an object and here's light coming in. So it hits the object, and kind of Alicia, like you were saying before, that like the normal, you were thinking of it as like how light would reflect off the object. That is not quite correct, because it's actually the way that the object is facing. So in this case, it's pointing straight up. But if I was coming from this direction, light would be reflecting kind of like this, off at an angle. So, but the normal is important to calculating that, because we have some sort of light that just comes in, and then we have to say, okay, well, is it coming in through back to the camera or not?
Is that what the dot product is for?
Yes,
That's
in
very
part.
normal. Okay.
Yeah, that's more for not the straight reflection, which is specular lighting. That specular is anything that's just like that hard reflection. That's why it tends to look white. It's just you're seeing the light bulb or whatever is giving off the light in the reflection of the object. And so then diffuse is more about like the light comes and hits the object, but it actually goes inside, and physically it's like bouncing around in a bunch of atoms or molecules, and it's being absorbed and re-emitted, and eventually it kind of just gets spread around inside the object, and then is bouncing straight out again towards the camera. So technically the light could be coming from like a different direction that shouldn't be bouncing towards the camera, that it like could even come from behind the camera, that it hits in here, gets reabsorbed, but then gets bounced back. So our Lambertian is just a approximation for like the ideal diffusion, like spreading of a light, that it will be much brighter as the surface is pointed towards the light, because that would be kind of like it's just bouncing straight off. Yeah. But will be darker in the opposite direction.
Cool.
Okay.
So if you notice that I have this diffuse function and I give it a float as the output, and that's because all we need is just like this dark or not type calculation. So if I remember this correctly, this is where we get in that dot product and then the ray direction. So what this does is that we know the ray direction is normalized, that it's all unit vector, and same for the normal. And why that's important is that there's not going to be some sort of scaling, that this is going to be just 1 if they're pointed in the same direction, and it's going to be 0 if they're perpendicular. Okay. And we don't really care anything past that because we can't even see that surface at that point. And it would also potentially just be clamped to 0. So we might even want to say, just for like being sanitary, I guess, we're going to say clamping to...
okay, between 0 and 1.
I think I also have to make these explicitly floats.
Yeah.
So that calculation is at least working, it's compiling. And so how we can look at that is we can say, we just put in, I'm going to call it as a variable diff. And what was the second? Oh, norm.
And the norm.
All right. Yep. So I think what I did
very
is
dark.
Yes, very dark. You know what I'm realizing? I think I should not call that ray direction, but I should call it light.
Why?
Because we actually don't care about the direction we're looking. We are trying. Okay. When I was talking about before, it was about the light and whether or not it's pointing towards the light. And so I brain farted, and I was instead doing it where it was pointing towards the camera. So instead,
right, because the ray direction looks the camera towards. Yeah.
Yep. So I believe it's from the camera towards the surface instead of from the surface towards the camera, which that was why it was entirely black initially, is because, and why it's still technically black, because though I called it light, this is still our ray direction that we're passing in. And that if we wanted to show up that right now it's saying like there's a vector pointing into the object compared to the normal, and these are going to be, as you can see, they're pointing in almost opposite directions in most cases. Maybe I should go like this. So that's going to always be 0. That if it goes from 1 pointing in the same direction to 0 pointing in perpendicular to one another, that as it goes, I can't really bend my hands like that, but as it goes below perpendicular, it becomes negative. Which is being clamped. So and a quick way that we can look at it and make it show up is that we just make the ray direction negative instead.
Yeah, okay. So then it's completely opposite.
Cool.
So but I don't
Which
think we want that.
You actually could have done here, right? In the, where is it, in the ray there, you could have say negative here instead of like doing it in the function.
Yep, totally.
Yeah, okay. Yeah, cool.
So now we have a diffusion function, but we need a light. And so I'm going to create a little light here. Maybe call it light post just to be explicit. I don't know if this is going to be a good position, but we can play around with this. So yeah, I believe what this is, the position should be that it's...
Wait, it's not a floating number, so...
It's a...
I mean, it's not an integer. Yeah, but you didn't put a dot? Can you do that?
Correct. Yeah, so when it's inside of a vector constructor, which is that vec3 and then the parentheses, you can, that's one of the few cases where you don't care about the difference, because it knows how to convert between both integers to floats and also from floats to to vector floods. So
Okay.
does that make sense?
Okay. Yeah. I was just wondering, like, because I thought like normally it wouldn't work
Right.
in GLSL.
Yeah, and so you can see that here you have as part of your palette function that it was a 1 without the dot.
Yeah, that's true.
But yet you can also do the 0 dot as well. So it probably is a good habit to do the dot always. And for people learning, I would always recommend that. Just like most of the time when you're dealing with numbers, you're dealing with the floating point version of it. You're not really thinking of it like, oh, this is going to be a whole number. The only case you do need that is for loops, usually, because that's just like a paradigm that you're thinking in whole chunks. So people tend to use integers. But
yeah, that is not decimal. Yeah, exactly. Yeah, that's why I was a little bit confused.
Yep.
Okay.
So yeah.
And
so
the light position has to be a vector 3 because you have to access the light from the 3 axis again, right? So that's why.
Right. So like you have your object here, and I'm the camera again, and this is the positive 1. Of sorts. Maybe I think it's smaller than 1, but this is in the positive z direction. So if I put the light, in your source or in your diagram that you have on the screen, that it's like somewhere over here or something.
Yeah, on the top.
Of it's like over here in front.
Somewhere.
So for us, it is kind of up here, I think. Then if I were looking at the object, you can see that I'm not sure if this is coming through correctly in the video, but like it's going to be on the right side of the screen and up. And so then the shadows should be cast on the opposite side, which is going to be the bottom diagonal.
Okay, cool.
That makes sense?
Yeah. Wow.
So if we want to, we can even go ahead and like rotate this object or this rotate? I feel like it is.
Yep.
I should look at how you define
I think we have a. Do we have it already here?
Yeah,
we have here up. It's a vector 3.
Yeah, on line 35.
The vector, the axis, and the angle.
Okay, so I think that's. Just for clarity's sake, I'm going to remove what we had before. And then now I'm going to say the axis. Let's do just y. And then the angle, right? So you have a time somewhere, right?
Yeah.
Is it u
I think it's u time.
Okay.
Yeah.
Yeah, I think that there's
You only got u two.
In the second vec 3.
Yes, I'm missing a 0.
Oh, I thought it was on purpose.
Nope. All right. Is this gonna work?
Cool.
All right. I think this is working.
Yeah, it's moving now because before it was static, the light, and now it's like moving as well.
So it's kind of moving like this, and as a halo, that here's our object. It's just kind of like haloing.
That's why you added the p, right? So or
pi. Yeah.
A pi. Sorry.
Yeah. So that was just so that over time it would, like we could say from 0 to 1, it goes one whole time or one half of the time. So, I guess that was only just to prove that we have a moving light and that we can move it around and it's going to create different shadows as we do so. So,
awesome.
Cool. So that's our diffuse part of our lighting. Now, if we want to get kind of creative, we might say something like, we can have.
Sorry, I was browsing back and forth Jamie Wong and this Michael's tutorial, and cool. So it's basically very similar to Michael as well, that he had this light. This is how I've been doing this ray marching, by the way, this week with the with actually putting a light for the first time and normalizing, which we weren't doing, but a lot of it was like just testing, and now I understand better, like especially the normal part, because the light I got it like, okay, it's a vector 3, so if I move it, so
Well, light is simple, I think, to wrap your mind around. It's like a camera. It's going to have three axes, and you position it in space. Sorry, I interrupted you, Sean.
Oh, I don't remember what I was saying, but yeah, I think that it sounds like making sense. And now I think what we want to do is, now that we got this light and we know the surface of the object, we want to start playing now with the color of the object, because so far it's been very black and white. That we just took this, like, how bright it is type variable, and now we've put it directly into a vec3, so it just gives us a black or white type color. Now, if we want to, we can do something like this, that will have a base color function, which I've somewhat put out already.
Oh, yeah.
Oh, and I'm realizing I need to add another thing.
Where is the base color?
It's just above the shade function.
Yeah.
Okay, just I'm going to scroll for people to see it.
In fact,
and you're missing a property. Direction.
Yep. Which is going to be important for our iridescence.
Yeah. I'm so excited. We're so close.
So as you can see right now, all that we've done is basically define the color of black being 0, right? So if I go ahead and just add in, you know, some red into the base color, now we have a red object, but it's still shaded by our diffuse Lambert shader. And that's because on line 117, we took our diff variable and we're just multiplying whatever color we get by that. And because it's 0 to 1, that's going to just make it either full brightness or completely black. Make sense? So now we get to be creative when it comes to what does the color look like. For whatever reason, I like to kind of just define the color as always black and then manipulate it from there. And one of the things that I like to do is I do use this dot product between the normal and the ray direction, hence me calling it D capital NR, that I say the normal, and then I do the negative of the ray direction, because like we did before, that we want it to be, we're actually thinking about, like, if the we were using the true ray direction, it would be negative, and we want it to be somewhere in the 0 to 1 range instead of the 0 to -1 range. So I just negate it there. And when I do that, then I can start using it for things. In fact, I can use it for the palette. That we have a vec3 now, but I can go like this. And then I remember correctly.
You know it by heart.
Yeah, normally I just write out the whole function because I don't know, I'm lazy in that respect. But I think that this should work. Is that correct? Yeah.
It's only vector trees. Yay, that's that.
Yeah. So this is like the basic version of iridescence, right? That as a surface is moving, like pointing towards the camera, or you know, slightly away, that when you have a piece of opal or, you know, some other like holographic material, that as you're changing it, that's where it's changing colors, is that the angle of the surface of the object is changing colors. And part of why this is that this is kind of a simulation, a grand oversimplification of microfacet iridescence, which is to say that there, at the surface of the object, it's got all sorts of different subtleties to it. It's not just a perfectly smooth object normally. So real life things, especially things like opals or like butterfly wings, that the reason why they're iridescent is that when you zoom in really close, there's a bunch of different angles on the facet, so that it's kind of creating this weird zigzaggy like shape. And it is so like small of a detail that some of those faces, like if you think about like just this one little bit of this grand kind of like noise looking surface, that it's going to be pointing this direction, and it's only going to be so big, and it's how big it is determines what color of light it reflects, because it's so small that the wavelength of the light needs to be a certain size and even to reflect off of the object. That if it's too big, I think it gets just absorbed in general. It doesn't perfectly reflect off of it. And my exact details on the physics is not, I'm not going to say that I know quantum physics or anything to be able to talk about that. So in the end, roughly the size needs to be a certain size to match the wavelength size of the light. And that's why you get different colors of light bounced at different angles, is because you have all these crazy facets pointing in all these different directions of different sizes. And whether or not the light reflects is dependent on whether or not it matches the direction and, size of the face.
It's like crystals, isn't it? It makes me think about crystals, because crystals, like if they're transparent or white and you put them in the sun, it's like you get this like rainbow. And like you said, if they have like smaller triangles within the crystals, you see like more brilliancy, as opposed if they have bigger chunks.
Then it's like refracting the light inside, right?
Yeah, so that's more of a dispersion type thing. But a lot of this is happening on the surface still, but it is somewhat similar.
So I have those bubbles that I always post, and I have a HLSL shader that I whittled together, and it's hanging on by a thread. But I can import a normal map that is bumpy, and that's what makes my iridescence look so cool. And now I understand normals a lot better and understand what I'm doing. Cool.
Yep.
Thank you, Sean.
Yeah, thank you. It's a lot of like aha moments today, honestly, like, because a lot of stuff maybe accidentally I came upon, and then I keep using it just because. But then,
when you stitch the thing together, right, you're making all of these assumptions, but it's nice to have someone who like
exactly like when you definitely know why.
Someone is asking if the D and R is also like a Fresnel ratio.
Yeah, so I don't believe so. I'm gonna actually look at
what's its a Fresnel ratio? I don't even know
Fresnel
what's
is
that.
another type of light.
Yeah.
The ratio, I guess, would be the amount of light.
Yeah, so the Fresnel light, what that is a kind of like we were talking about with the microsurfaces, that there are different properties of how light reflects off of an object, whether it's smooth or not. And when it gets to the edge of an object, I don't fully understand the phenomenon, but like there tends to be a highlight on the edge of the object. And you'll mostly notice this in like on cars at night or something, that like you'll see, at least this is where once I learned it, I was driving along and I noticed that the car in front of me, that it had a highlight on the edges of its shape, like when it goes from being car to being like, the road or whatever was behind the car.
Okay.
And the reason for it is that when you're glancing off, when the light, this is the surface that we're looking at and I'm the camera. So as light is coming in, the only light that can possibly reach me from this angle is going to be ones that perfectly bounce off the edge like this. And I believe there is a physical phenomenon that more light tends to bounce off at that sharp angle. It certainly is in part because we were talking before about like light bouncing into an object, that especially for something like dispersion, like Ilithya was talking about with crystals, that you look in, the light comes into the crystal. It has one of two things it can do for the most part. It can either reflect off of it perfectly, which is where we get like specular lighting, and just straight up reflections, that when you see a mirror and you're seeing yourself in the mirror or whatever, is at that angle, that is all, I don't know if this is technically accurate, but it's basically specular lighting, because it's exactly the light source that's coming in is being just immediately reflected off and comes off. But the other option is to refract into the object, and that's part of where you get into diffuse. That diffuse lighting is sort of a refraction inside, but then immediately it bounces around and comes back out. Versus dispersion is going to be all about refracting, that as it goes into the object, the light is being bent slightly, and that has to do with how the speed of light changes inside of one object versus another. But I think that is much more into like the dispersion end of the spectrum. Yeah. But when it comes to Fresnel lighting, I believe that there's no part of that weird interaction of what determines what is reflected versus what is refracted, and the proportion of the light that is, depends on that speed of light inside of the two objects, and also the angle. There's something called a critical angle where it no longer really can be refracted inside the object, it can only be reflected.
Okay.
And so I think that's where there's a boost to the highlight that's on the edges. So yeah, so Mario's correct. That's why I thought of Fresnel that
want the halo.
Yeah, and I mean, I think to a degree he is correct that DNR is Fresnel, but it also is not. And the reason why I said not is because I think proper ratio would be using the speed of lights inside of the object. I have had in the past that I've calculated that you do, I guess it's like, yeah, it's just you take those two numbers of the speed of light in each one of them and you do a certain calculation. And that's kind of what drives it, but it's still based on then the normal and the ray direction as well.
Cool.
So
is it like, so if we have like our perfect normals, is there like a way, I mean, I assume that the answer is yes to this, but like, because I'm used to just importing a normal map, but you can mess around with the direction of your normals without needing a normal map, right?
Right. And so when I was talking before about the texture of the object, and I said that you could either do it in the scene in the SDF, or you could do it with the normals later. That's what normal maps are, is that they're perturbating or moving around the normal somehow. So if we wanted to mess around with that, we would do something, maybe we should do it in like the shade function. So I'll do it right underneath where we actually get our normal, that we can say something like, I'm just going to take the sine of it or something. That it looks roughly the same.
It's the same. It's the same.
What about this tangent? I feel like tangent would make it weird. I always put that because no one uses tangent.
Yeah.
Like the forlorn function. I plug it in everywhere because I wanted to. Oh my god.
Yeah. Now
cool.
then you're gonna. Okay.
I knew it would do something weird like that.
Yeah.
It's like, that's funny. Okay.
So yeah, wow. You can do all sorts of things, and you can also do maybe like some sort of perturbation where I'm gonna say like sine, and then you should probably still normalize again if you're messing with it.
Why?
Because
why do you have to renormalize?
Our calculations are based on the idea of it being a unit vector. So we're not losing the direction changes that we're making to it, but instead we're going to still need it to be like a unit, so that when we're doing the Lambertian, like we were doing before, the diffuse part of it, that it's not going to be something crazy. But
ooh,
yeah, so you can.
That's nice. Whoa,
yeah,
wow.
So I created this sort of texture by creating this like
yeah
small changes based on itself, but like really fast.
Hold on, and if we don't normalize, I want to see what's the difference.
Sure,
so
yeah.
If you actually see it, or
yeah, you probably don't see it a lot.
Does it change? There's a little bit of a difference.
Yeah. So
there's a little bit. What if you add?
Maybe it's a little bit more accurate with normalize, not more like.
Yeah, and so it would be
crisp.
More dramatic if we did not like on line 111. We are only adding at most negative 0.1 or 1.1. I mean, so if we made this like 2 or something, and then well, first off, you can see like that's crazy now. It's greatly affecting it, but there's still just like blackness and.
Is my time doing anything? I don't think my time is doing anything.
Yeah, I might have.
No, because we already have
it.
so much time, probably.
Yeah. So.
Oh, that's so cool.
Yeah, not normalized.
So creepy.
I don't know if you can tell a difference because it's so drastic.
Yeah. It's probably very tiny. I imagine it's to add some crispiness and perfection to these like tiny details that you have. That probably, if we would zoom in, probably we would see it. Yeah. But from here, we don't.
Yeah, and certainly I'm driven always by like mathematical perfection and accuracy, right? So, which
I'm enjoying that. I'm enjoying to learn that part, honestly.
Yeah.
So.
Ilithya is also very accurate. She comes in with her design eye. I come in and I just kind of poke at things.
Is
I'm very messy.
yeah,
But I think that's important to have, you know, this like
oh yeah,
not be
that's the creative
some
process, right?
exactly, yeah, that it's not sometimes planned but accidentally
Yeah,
something
my
that
stuff is
happens.
very much accidental.
So
Yeah.
spontaneous too, you know. So.
Yeah. I kind of just like poke until I see a thing I like, and then I'm like, oh, let me scratch at that some more, see where I think. And then I
that's often
reverse
how,
engineer.
yeah, I would say that's often how I do it too, because that's one of the reasons I love ray marching as a technique is that it's fundamentally about discovery, and that why I often when I talk about this whole like bring metaphysical math objects into our plane of existence, that like that it sounds way more highfalutin than it actually is, because I basically all that is the ray marching algorithm for the most part, and that I can then just throw it some random math and it will picture it for
something beautiful.
Yeah, and that's part of where recently my gyroid based stuff.
So good.
That was me literally like putting in the gyro equation and saying now render yourself, and I brute forced it, but ultimately it's you get to discover, you literally turn an equation into a shape. So
no, I love it. Which is a perfect, it's a perfect full circle to what you were saying at the beginning. I don't know if you want to keep poking or not. I just noticed the time and I want to be respectful of your time.
Yeah, true. It's already 8 p.m. What?
For us, but for you, it's like midday. So I don't know if you want to have lunch and like go off and do your thing. But I did find it very poetic the way you brought that back around.
Yeah.
I mean, I try to be consistent at least for everything. So, as far as time, I have probably about at max another hour more. But so, yeah. My parents are actually in town, so they're meeting me in about an hour. So.
Okay.
So
then you let us know when you want to leave then.
Yeah, that sounds good.
So just tell us like, hey, I think I'm gonna leave, and then we say goodbyes.
Sure. So one of the things I changed that I'm not sure.
Where are you? I'm trying to find you.
Well, I've been jumping all around, but mostly in the scene. I think it's maybe the important part.
Which line?
Line 49.
Yep.
Let me so people can see what you're doing. Okay, yeah.
Sure.
Cool.
Because you zoomed us in there, I think.
Yeah, I wanted to ask what happened, like.
Yeah, so I think that why this is happening is because, if I remember correctly, it is because down at the very bottom in your main, when you're constructing your ray direction, I think that having that negative z, negative 1z, is a simple way of doing this, and it doesn't truly like encompass all of the math behind camera projection. So truthfully, this is how I started, was with this kind of negative 1z, and then I eventually knew that it was limited and that certain things would kind of just like zoom in and do weird things. It didn't feel like a real camera.
Okay.
And eventually I went into doing web VR versions of ray marching, and I needed it to be really accurate, because otherwise it would screw with your vision and you would feel nauseous. You know? So I just looked it up. I don't remember the math. It looks vaguely similar, but it's maybe technically more accurate. So I don't know why this is happening.
Okay. But if we make it like -5, will it zoom it out?
Actually, that's a good point. I wonder if it is just because of how close it is.
Oh, now we're really close. Oh, so I need to go to
Hold on, because Eliza was changing.
Right. So I think that first off, it wouldn't be there that we'd be changing. The closeness is the position vector.
Right. No, right.
So,
right there.
Yeah, but it is maybe related. I don't know. This is at least getting better. I'm going to go to 3, make sure that we're clear. So now we can see it. There's the object, right?
Okay.
I guess what I was trying to do back on line 49 that Eliza pointed out is that I removed your rotation by just redefining it to be the position. And why I wanted to do that is to like not obscure what's going on the surface with our shading and stuff. But maybe what we can do is we can swizzle a little bit so that we can orientate the donut like this. So I did that.
Back. 1 second.
Sure.
So just rotating to like one angle, so that we see that face.
So I swapped the X and the Z, and that gives us that face. So yeah, Mario was recommending that we do more distortions to the shape. So we can either go in that direction, or we can talk more about iridescence and potentially ways of making more interesting colors, or really up to maybe both.
Yeah, because I'm really happy to just learn more about iridescent. Yeah, let's try to do both. So that,
okay.
Because it's very interesting to see how you can achieve all of this, like lighting, moving, the colors. It's like blowing my mind.
So what I'm going to do real quick is I'm going to do something like this, that I'm going to say, I'm going to do warping of the object real quick, because I think that's going to lend itself to doing iridescence, that instead of having the motion that causes the object's faces to turn being the rotation of the object, we'll have the object itself is moving like this or something.
Okay, yeah.
So how I tend to do this, just because I like to think, again, as things are being kind of discrete, that I want to have the distortion of the space that the object is in as almost its own variable initially. So that's why I set on line 51, I have this W post.
Why did you call it W, by the way?
W for warp, and then post for position. So I actually tend to call it WQ because I call all my positions Q for some reason. But
okay. Indigo too, I think so.
Yeah, I think that's where I got it from. It's definitely not my own original idea, but yeah, it is interesting. I just kind of pulled it up there, and I think that post though is better because it's going to be more verbose. So now that we have that, I like to then do my distortion within these two lines. Because that is how I kind of, it could be a whole function. It could be also just like in line here. For some reason I do it in line. But one thing that I do a lot of for my distortion is doing cosine domain warping, which is really just using cosines to push around the space that the object is inside of. So I usually will have a const float that represents the whole scaling of the warping, and I'll put that initially to 1. But the basic premise of the cosine domain warp.
What is exciting, this is going to affect the light too, right? So once it's warping, so...
Because we're changing the shape of the object, and we've been so far, deriving our normal based on the shape of the object. And so one of the nice ways about using that numerical approximation of the normal, instead of trying to mathematically solve it, is that if you mathematically solve it, you have to do it for exactly your scene. And that's probably difficult. At least for me, it would be difficult to do for every scene that I do. And it doesn't respond at all to your scene. So you would end up just like, you'd be doing a lot of math and calculus trying to get to that point. So I much rather kind of had something that just gives me a good approximation that works in most cases. So how cosine domain warps look is that you kind of have this basic premise of doing a small shift into the object or into the space itself. So each line will look something kind of like this, where you have your position, you're adding to it, you're keeping the original position, but then kind of shifting it back and forth. And this warp scale is how we're just modulating that. We can adjust that later. That's kind of more as an aesthetic thing, like how much of a warp do you want? And then here is a scaling factor, which for me, I always start at 0.1 because that tends to be a safe number.
But why did you add it like so many zeros after?
You'll see when I add more layers of the warp. I tend to do that just for aesthetic of the code because it's possible we'll use that many decimal places for the lowest tier. But initially, it's going to be 0.1. And then at the same time, you want to add complexity and details. So one of the things you do, instead of just putting the position itself into the cosine, you can scale it up so it becomes more detailed. Like there's going to be more of a change in every spot. And I start with 3 because I like using prime numbers as much as possible to create as much complexity in how they interact with one another. And you'll really see that when I get the other layers on. But yeah, it's the basic premise of how one line of the domain works, is that we have an overall scaling at warp scale. We have then a sort of set for this line only. This is how much it's changing. Then here is the frequency of the space that we're warping around based on. And then something I didn't mention before, but we're swizzling or swiveling the coordinates so that the y is affecting the x, and the z is affecting the y, and the x is affecting the z. And that allows you to kind of like mix different dimensions. Makes it a lot more interesting ultimately. So that's one layer. And what I tend to do is that I go down, and this first number that's kind of the amount for that given layer, I just divide it in half.
Yeah, I see now why you put so many zeros.
Yes. Okay. So we're going to be adding more and more layers, and it's going to create a smaller and smaller number. But doing half is kind of a nice way of saying like that first layer did a lot of change, and then this next one is going to make a less of a change, maybe approximately half the change.
So you can actually see it. Otherwise, if it would be in the same anyway, you wouldn't almost notice it.
Yeah, it's that when you have, if you're creating complexity within a function, if you do something that's equal power, you're going to maybe just get like straight up cancelization of the two. That if one happens to be full -1 and the other one is full 1, that you're just going to get 0 and you're going to have maybe less intricacy. But if you can somehow make it so that they don't line up perfectly, especially since we're using the same function, which is cosine, the more variance we can add, the better, I think. So yeah, adding a different amplitude, which is that 0.05 now, that's going to make it not as much of big changes, but it's going to add these little changes now. And then another thing we can do is we can add a different scaling factor to how the space is put in. So in this case, I use maybe 7, or if I want it to be faster, I'll use 11. And so
I
now
found curious that you said that you stick with prime numbers, right? You said that before.
Yeah, it's so that their period, because this is effectively the frequency that we're using, that we don't want the periods to line up if we want to maximize the way that it changes unpredictably. That this way, it's not until we have a common multiple of the 2 primes that we're going to get something that repeats. That wherever it is that, maybe it's like not even exactly multiple, I guess it might be like a division or something. I clearly haven't thought this through 100%, but like there's a point in like X, for example, where this 3 and 11, that they will repeat again, that it's going to be a third for the 3, but then it's going to be 11th for the 11. So wherever that happens at the same time, that's where the pattern that we've created will repeat for X.
Cool,
if that makes any sense.
Oh my goodness, my mind is so blown. It feels like it feels like playing with clay now. So
yeah, I often talk about using math as though it was clay. That you get to start pushing and pulling, and in this case, we're just using math to do it. You know,
molding.
Yeah.
I'm pretty sure I remember Patricio telling me that he also tried to teach SDS as like Play-Doh to people. That he used a similar analogy. Oh, it looks so cool. I was just picturing in my mind, if you were to put this shader on a 3D object, would that mean that you had a pattern of ray-marched blobby things? Like, so right now we have 2 triangles, right? And we're ray-marching in 2 triangles. But if you were to integrate that into like a larger 3DS scene, would you have like a pattern of ray-marched objects?
Yeah, so you can use this domain warping for maybe the vertex shader of a normal. So then it would probably do the same thing, because it's doing it only per vertex, you know, but that you would still get these kind of weird blobby type shapes.
So cool.
Yeah, so I added a little time, and it's gonna now move in that very fluid-like way. That I kind of liken what this cosine domain warp does, that it's kind of like looking through imperfect glass, you know, like you have glass that's kind of got all these like, not bubbles, but like it's not perfectly flat on the surfaces. It kind of warps things as you go in. And if we want to make it more dramatic, we can like multiply it by 10. And then suddenly now it's so dramatic, it can't render properly.
Yeah, no.
That's wild.
What did you have before? 1? Or...
Yeah, 1. So
Okay.
1 is just kind of like the uniform default. But here's 2, and it starts getting even more melty.
Yay.
And I think you can see it at the edges. It starts to tear a little
bit.
But
is it that does that have to do with like the, because I had that problem with some of my
I think they did that
ray march, and I always change the ray march max steps, so, and then I get until the crisp levels.
When we did the last ray marching, when we had our 2 objects and we twisted it, I think it had the ripping thing a little bit.
Yeah, both those scenarios make sense to me. That you can change the max step, and how I've done this in the past is that maybe we can still do it. I think if I go down to our ray marching function, and where you're talking about being max step is not the max distance, right? So that's basically this default return at the end of the function. And so we would know if it's the max step that we're hitting by setting it to, it needs to be a vec4.
Oh yeah, true.
So what we'll see now is that there will be magenta, and granted we have magenta in our color of our object as well, so it's kind of hard, but if you notice where a magenta does not dim, then that would be us hitting the max step, and that happens usually at the edge. Now, to fix ripples or tears, you can do a bunch of different things. Ripples and tears could be a max step error, but tends to be, in my experience, that where it tears, instead of having kind of like a clean line that just is like blackness where it shouldn't be black, or the background color or whatever you're using, that would be the max step. It's like when you see the background color where it shouldn't be, that's max step. Where you see tears tends to be more of a inaccuracy in your SDF. So your sign distance field is designed to be like the algorithm assumes it's accurate, that this bat, as it's moving through the space, it's got a certain distance, and if you lie to it, then it's not going to know what to do about that. And when you're doing this cosine domain warping of it, if you think about how cosine kind of goes up and down, right? That means if you think about just one dimension, here's our object that we're kind of like pushing and pulling it in, say, the z direction, that as we do that, we're doing it based, in this case, if we go back to the scene, that we're inputting it based on the space itself. So it's possible that as you are closer, that you're going to have this small pocket where you've pushed the space so that it's actually like showing the object. But because you were ray marching like right before it or something, you might have gotten a bigger distance because it's not like we're pushing and pulling space. So in that space that it calculated at the moment, it was the correct distance, but it doesn't, I don't know, I feel like I'm not making a lot of sense, but I think in the end, it's kind of like if you're warping space, you could have it where you see yourself multiple times, right? And so that can happen inside of here, even if you're thinking about just right off the object. So that's part of why the distance is wrong, is that you're kind of like, it's like a funhouse mirror in the sense that you see yourself multiple times.
I was going to ask if that,
Yeah.
True.
Or even more accurately, like the funhouse mirrors, how they have it, if it's like kind of rippling like this. So imagine yourself that it's going to show yourself potentially multiple times with each ripple. That if you were kind of trying to come from one direction, you might hit a part where you say, oh, I have plenty of space, but because you've been squeezed into the small area, you will actually jump over yourself but then, you know, depending on the exact accuracy, sometimes you'll hit yourself, sometimes you'll miss yourself. And that's what's happening right at the edge, where we have this small area where we need to catch things. It could be jumping accidentally past it, potentially.
Okay, so like funhouse mirrors, but then also those bathroom mirrors that turn in on themselves on that.
Yes.
You know what I mean? Where you see
yeah, I think that would count too, because you're seeing yourself multiple times, you're seeing multiple edges of yourself. Yeah, I think that works.
So cool.
Okay, but then how would you fix it? Now it's a question.
That is a great question.
Still.
Yep, totally.
I mean, I like the little tears, but we
sometimes I do it explicitly, but what I tend to do to fix it is to add a understep, is what I call it, and I think that most people call it that. If I go to line 64,
okay, yeah.
At the very end of our scene, I usually take
where
whatever
you
distance.
return the shape.
Yes,
that's where you are, right? So yeah.
Yep. And so you can see I put 0.4. The reason I did that is that because what the real problem is when the ray marching algorithm gets a distance that's too far, right? Because if we're a blind bat, we really want just a minimum distance, something that's safe to move forwards.
Yeah.
And if it's giving us something that's inaccurate, that's actually saying you can go further than you actually can, then that's where we get these weird tears. And so if we just tell it always to go less of a distance, like get rid of all mathematical accuracy at where you can exactly say how far you are from something. Instead you say, I know I can safely tell the bat it's half the distance that I would calculate normally. Or in this case, slightly less than half. You know, it's going to be 2/5. Okay. That allows you to it tells the bat basically to be more careful as it's moving forwards. That it's moving slowly. Getting back to bats, but that.
Yeah, no, I like the analogy of real things.
I like the consistency of the analogy as well.
Yeah. So telling the bat to go slower, it's like changing the speed limit or something. That allows you to not overstep, because even if you told it to go twice the distance, we would still be easily not hitting the object. And now you can see, I believe that there's not any real tearing. You'll see a little bit of that magenta that we used as the
in the outside. I was going to ask about that outline still. I mean, it doesn't bother me, but could you get rid of that one too, or that's just part of it because of our background?
Yeah, well, it's not part of our background. It's the
no, I mean that it's so close to the background color. Probably that's what I wanted to. Like if we would had a white background, would we still see it?
Yes, you would still see it. So we can even do that real quick, I think. I'm trying to remember. I think this is the right margin.
Here, I think is the background.
Well, that is not the background color anymore. That is now the we've reached the max step color, and so it's more of a debugging. So like normally you would just set it. Yeah, exactly. So we would normally.
White?
Yeah, if you want, you can set it to white. And so this will now show white. You'll still see.
It's still there.
Yeah, but it's very faint and it's hard to see because the brightness is now more similar. But yeah, that it is still there. And what we do is what you did originally, that before I changed it to be a sort of debugging type color, is that we just set it to be the background color, because this can happen and generally should happen right at the edge of your object, because then your max amount of steps is just enough to cover those worst case scenarios.
Yeah, now I see it sometimes, but not when it's on the edges.
Right, so you can see some of the glintering that is the white.
Yeah.
And you especially see it on the dark parts of the object. And that's where
the black, it disappears.
Yes, exactly. Because that's a little bit safer in general.
Yeah. I mean, you see it differently now, but yeah, in a different way.
But I don't think that the like edge of the pink that you see now isn't you've gone too far. That's just actually part of the movement.
Yes. Yeah. All magenta now is actually part of the color of the object. Yeah.
Cool.
Yeah. So.
I really love this piece now.
Yeah. So cool. Yeah. So, I really love this piece now. So,
I really love this piece now. 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 I really love this pi
Where was I going to go with that? I think that one of the things that this points out is that doing understepping is dangerous because you're just, even though you're making it safer to do other dangerous things, that it still has its caveats, and that the reason why we were seeing little dots of white when we had the white background inside the object is because it thought it was the background. And that's because when you set inside of the scene and you set it to go slower, you're more likely to reach now the max step because you've now told it to take a smaller step every single time. Okay. So as the bat's moving towards the cave wall, if it originally took only 3 steps, but now you've told it to move a third of the way, it's gonna take 3 times as many steps. It's gonna take 9 steps, and maybe your max step was 5 steps. You know, like you're gonna be more likely to hit that threshold. So that's where usually I will, if I need to add a understep with this speed limit of sorts, I will ultimately also update the max steps if I need to.
Ah, okay. Yeah, because that's my hack normally. When I found the edges that are not crispy, I just put a little bit higher number and then it goes. Because that's maybe as well a question. What would you like start normally when you do ray march? What would be like your max steps? Because this is as well something that I see different in every like tutorial, and even myself sometimes I have to tweak that number depending on what I want. So is there a number that you normally have, or you also have very different depending on what you're actually trying to render?
Yeah, definitely is dependent on the shape, because again, if I use a lot of cosine domain warp and I make it really strong, I'm going to need it to be bigger because I'm going to be putting on that understep. But the ideal is that if you have a perfect SDF that doesn't have any weird distortions and give you accurate distances, it should be relatively small, like maybe max 128 steps with like maybe more average 64. So yeah, it's I have very often had huge max steps will be something like 2048 or even, you know, double that. So like 4096 or something like that. That those are where I'm doing, like I am trying to push it to the breaking point as much as possible. So
okay, cool.
Wow. For this one, Mr. Glocks, it is not an icosahedron. It is a torus, which is a donut. But to Mario's question about what is my most common shapes, it tends to be either really a box or a sphere, because spheres are especially good for iridescence because they are smooth shapes. So they're going to have lots of change in surface, versus a box will have just like giant faces that face all in one direction. And the only way to make them smooth is by doing a domain warp on top of them. But
you did some like peely ones once too that were really cool. I mean, you did that a few times. Do you know what I'm talking about? These like
the orange that literally peeled, or
oh, I don't think I remember
which
that
one. Yeah, I don't know which one you mean.
I mean, I don't know if it was, no, I can't remember if it was recent or old. But it was like a bunch of rectangles that kind of like came down.
Maybe you can find it for us, because otherwise I don't know which one.
I'm trying to remember,
because he has so many different ones. That
I think I had something around like 1,500 different dailies. So
really, wow.
Yeah, I mean, let's see, if I do 4.5.
I'm remembering it because ilithya scrolled by it before, and I was like, oh, I forgot about that one. It was like pastel kind of.
Ooh. Maybe
I also really like the self-cutting boxes. Those were awesome.
Is it this one on screen?
Gonna take a while to see it.
Oh, okay. Yeah, it's lagging.
The one with a bunch of little cubes. Yeah.
Yeah.
I don't know which one. I'm just asking if maybe that's the one you meant. No.
Oh, no, not that one. But I love all of them. I think Sean knows because every time he posts one, I'm like, oh my god. I love it.
Yeah, me too.
Yeah, you guys are some of my biggest fans.
Yeah,
I really appreciate it.
Yeah, I feel like you must get like like when you post, I'm sure everyone reacts to them, no?
Yeah, a decent
Yeah.
amount. I mean, like certainly most people just react with a like. You know, that's the simplest interaction. But
no, I'm more vocal than that for sure.
Yeah.
Like,
yeah.
teach me your way.
Bye, Raphael. Yep. I do get a decent amount of those, but people will ask, you know, how do I do this? Some people say, what software do you use? And I have a stock response. I don't know if you've noticed this over the years, but like I just have something that says I write my own software. Yeah.
It's this one from April 17th of 2020. Let me see if I can send it to you on Telegram, Eliza.
Oh yeah.
That way you don't have to like open the chat or whatever. Here.
I think I see now. It's called Slit Scan. Is that the name of it?
Nymphs in Song. Also, I meant to tell you, I really love how you name all your things all the time. They're so cool.
Oh, thank you. I try to make them unique.
Yes.
I actually
Do you
have
see
a program.
it now, by the way? Do you see it?
Yeah, I see that now. Okay. Yeah, so for this one, what was your question again? Is it like, how do I create this shape? Or
I was just telling you that I love it, but I'd love to know how you made it. If you feel like telling us, sure.
Yeah, so this is, as you might guess, is a box. And then it's just elongated. And then I do certain, like, you can also you can bend the space as well. I think that Inigo has something he calls like a cheap bend, which is just like, much like your rotation matrix, that it does that, but just kind of locally and usually only on one plane. So I have it bend so it becomes this S curve. And then
you're bending space there, not the actual object?
Correct.
Cool.
In part because like usually that's the easiest way to do it, because doing bending the actual object probably requires a different sort of math to it, you know? Whereas I have these kind of general tools that are my clay manipulation tools, and I just say, do it this way. And
wow.
So then, in addition to that, I have so I have only one box, I believe, in this render, but you use space repetition in order to get multiple boxes, which is maybe even something we can do inside of our shader that would be new, is if we add on
where are you?
I'm in scene, so it would be like 53 or so.
Okay, cool.
Bending space and time. This is why I love shaders.
By the way, I was checking, and I also had liked that shader from last year. So I totally forgot about it. Probably around the time I found you on Instagram, I think.
Yeah. All right, so I think this will work. I'm trying to remember. Ooh, yeah, maybe I need to do this more accurately. Let me look it up. Yeah, so I'm splitting up space a little bit, maybe too much.
No, I love it. I feel like I'm tripping. This is amazing.
So I'm actually going to...
Where are you now?
Sorry, I was in my own code.
Okay. I thought you left somewhere. I was like,
no. Am I actually able to paste? I'm not sure how this works. Yep, there it goes. A little bit. I messed it up, but... Sorry, while I fix this. That worked. So if I say, change all these P's to W post, or post. But now I'm just kind of translating things, but I'm now going to call a vec size. I'm just going to say something like this. Get rid of that line. It's going to be correct. Guessing this is an error still.
Yeah, we can look in the console. Hold on a second. Oh, there's a lot of errors actually. Oh.
Yeah, it keeps a history.
Yeah, I clear it now, and let's see what's the new one. Now,
size redefinition. Where did I redefine it? Size? I see. It's down at the very bottom here for your torus.
Oh yeah, true. Size.
So I'm going to call your torus size an R. if that's okay.
Yeah.
Mm.
All right.
Oh, okay.
Okay, at least we have something.
Something's happening.
Again.
Yeah.
Whoa. Okay.
Let's maybe try doing it in one dimension or in 2 dimensions instead of 3, because I think that might be part of why this is happening.
Oh, this is what I was doing today, actually.
With your
Inigo has a function to kind of make repetition. And you can do it limited or not. And he was using this round function, and then for me it was not working. So then I use floor like you, because for me, I don't know where he got this round, which I don't think is in GLSL anymore or something.
Yeah.
Did they remove functions?
I have no idea, but he had let me show it to you, because I was using it today.
I think it's a difference between OpenGL for WebGL versus OpenGL by itself.
Could be, because for me it was like, look, I put it up now. So he has this round here now within the function, and it was not working for me, and I just swapped that to floor, and then I was able to access the function and do this repetition. So that was like, okay. But I wonder, like, why did he grow it round? So
right, yeah.
Maybe.
Definitely when reading anything from Inigo, you want to translate it a little bit, because I think he does a lot of his programs in C or like OpenGL in general. So you'll see like ampersands in some of the arguments, and that's like a reference type thing. And so, yeah, I definitely like think about it as just code and then try to figure out ways around it. So
what it means. Okay.
Yeah.
Oh, there's like little slices in here.
Yeah, so that's some rendering errors of sorts.
I see. I was like, oh, that's so cool.
Yeah.
I love it. Now I see the repetition a bit more clearly.
Yeah.
It's getting better. Fractally, kind of.
It is very fractally.
Yeah, now it's getting fractally.
I think one of our problems is maybe the size. Maybe I'll just make it even bigger so it repeats less often.
Okay, yeah.
See if I can make...
My computer was about to
explode.
Where did you go now?
Sorry, I went to the very bottom. Now changing the camera to be a little bit further away. Hoping that will... We're probably going to hit a max.
It's smoother for me. I don't know if it's smoother for you guys.
Yeah, it's pretty similar. I don't think that's helping us.
No, I don't see a change. When you swap the camera, I don't think it was a big change.
Yeah, and I think that's because we're not truly doing the camera projection perspective. But and really quick to answer Mario's question about my enumeration on my dailies. I do that as a Braille character. I use it to encode the number of the daily based on it's really random, but Braille itself originally was a 3 high and then 2 across. So there was a six dots in a grid. And then they added a 4th row, and the numbering then is, I think it's like 1, 2, what is it? It's 1, 2, 3, 4, 5, 6. But then because of this new row, they added on 7 and 8. So there will be some confusion. It's not straight up clear binary because it goes in this weird pattern. But if you take that, then the top left dot is going to be the 1 column for binary. And so as that you see from day to day, you'll see that one is basically flipping on and off constantly. And then it's slowly incrementing up all the rest of the dots according to binary. But I wrote a node module that converts between the two. I think it's called binary Braille or something. Yeah, very cryptic.
Why were you interested in Braille? Just because of the binary aspect of it, or
yeah, I think it was very
else?
Naturally conducive for binary, and that was an efficient way of encoding as like a single character. That because you get basically 8 dots for every one of those characters, and it's pictorially representative of binary, even though it's got this confusing order. And if I have two characters, I will probably never be able to use up all of the numbers that can show. Versus like if I were to like type it out, it would be it would be at least 4 characters long, because it would be like 1,600.
That's true.
Blah.
That's true.
So
Probably I'm doing the opposite as you, because I'm doing the Roman numbers, so sometimes they're very long.
yeah, yeah. Yep.
Cool.
So it's always fun to just use different number systems, and
Yeah,
for me,
I do the same. So I took the Roman. So.
Yep.
Cool.
So, yeah, I think the reason why we're getting this weird flip is because somewhere I rotated it, and so right now we're repeating. If you look on line 56, that we're repeating on X and Y, but Y is actually like, because I rotated it, that is that it's kind of what our camera Z is. And this is one of the dangers of rotating, especially preemptively, is that you can kind of get in trouble and confuse yourself. So I'm actually going to move our 64 is now where we're going to do the rotation.
Okay.
And I need to change it so that it doesn't say posts. I need to make it rotation itself. So instead of where we were rotating it before.
Oh, okay. So that now you have
you see the grid, and it's now rotating around that grid as well.
Wow.
Yeah.
Cool. They look like little donuts. Those like colored donuts.
You got some trippy donuts.
Oh, now I'm getting hungry.
Me too.
Like the ones that are filled with cream.
Yeah.
Wow.
Yeah, with the glaze on it. Do you? I wanted to ask you, for your dailies, do you actually like every day sit down and then post the one that you make that day, or do you really?
Yep.
Wow.
So I mean, that's where I was talking before. It could be like 5 minutes to like 6 hours or whatever. That I will use the code from the previous day, so it's never like completely from scratch. That I could never do. That,
but you iterate. You said something. You iterate from the code from yesterday.
The day
So you
before.
take okay, and you always go like that. You never
Yeah, sometimes I'll deviate dramatically. You know, like maybe I will wipe it away. But as I'm better about keeping functions nice and tidy and clean, like doing like here's how I warp in general, that allows me to just kind of compose things together instead of having to derive them every time. But
okay, interesting. I thought maybe you will maybe have some batches one day that you can create many for the week already ahead. So.
Yeah, so it has
Go ahead.
It has to be every single day, and my day is when I wake up and when I go to bed, and like I kind of alluded to, I'm a night owl, so technically I'll post it on the next day usually than what it's supposed to represent. But so doing different iterations every single day helps you practice, and it forces me to be creative literally every single day. Talking about like things like anxiety, and then also like the weird like
that's why I don't do dailies, because now you're making me change my mind about it slowly.
Yeah, well,
if I do every day based on the day before, I could maybe pull it off.
It's just you have to find your style, I think, when it comes to daily, because remember, it's like when I talk about this like challenges that it was supposed to be like every day, and that's why I called this any day shaders, because I was like, okay, maybe I don't want to do it every day, you know, right? But I think it's just about to find your style, and maybe dailies like 365 days a year will not be for you, but maybe like some months of the year. So
I just remember trying to do Codevember but starting from scratch every day, and that was, I think, my main error.
Yeah, that's always harder.
I definitely try to be kind to myself, and that's ultimately what I've learned from the daily practice. That besides, like, obviously, I'm getting better at being a programmer, being a graphics programmer, but ultimately, like having anxiety, like a lot of that comes with like perfectionism and other ideals of ideals. You know, like I have to make something that's perfect every time, and doing and that's where like I generally recommend some sort of daily practice, though I think it has to be caveated with like it is anxiety inducing, and that's always a danger. But if you can allow yourself the grace of being able to say, I'm going to make something no matter what it is, and I'm going to have to put it out there. And by publicly announcing it, you're facing potential ridicule.
Yeah, it doesn't have to be perfect every time. It kills me sometimes too, but I had to let it go.
Right.
Because otherwise I couldn't do as much Like the times that I do more is because I'm not caring too much about the perfection. Otherwise, yeah, I cannot post.
Yeah, totally. And I've also found that my calibration for what is perfection is kind of wrong. Like it is totally this golden idol that I've like bowed down to that nobody else worships, you know, like that when I put something out there, and actually a fair majority of the dailies I've done, I don't like. Like I actually,
they're so beautiful though.
Exactly. And so like me
Yeah.
thinking to myself, like, I wish this is not what I wanted, you know, like, and putting it out there and then getting instead response like Eliza's, like, you know, that ultimately people love it, you know, like they're like, for example, I worry that my style is too repetitive, that
You told me that once, and I was like, no way, because I mean,
yeah. And so it comes from me knowing like I just have a bunch of cosine domain warping on top of some random shape, you know, like, and that gives me all the blobs for the most part. You know, it's some combination of cosine warping and like a twist or something, you know, but ultimately it's still, I think that if I look at another artist, I wouldn't blame them from using the same tools over and over again, you know, especially with like,
no, sometimes having some constraints is easier on the go, you know, so
right. Especially if you're doing it every day and you just want to, you have 5
exactly.
minutes, you need to go to bed, blah blah blah.
Yeah, exactly, because if you have like unlimited random choices, then it's harder, of course, to make decisions, because then you have to decide each of the steps. So having some constraints on what one is doing, no matter what the art is, I think sometimes is good. If you're like trying to like achieve, especially like we were saying, like often. If you have to do one piece like for 1 year, then maybe okay, let it be completely unlimited and take the time, you know, to work on it without the limitations and constraints.
I had seen a video of a guy who's trying to learn to draw, and he basically was told to draw the same duck every day forever. Every day just draw the duck, and eventually he started branching off and drawing different types of ducks, and then he just started drawing other things. But just like the repetitive action of doing the same thing over and over, it was what allowed him to like develop the, I guess, wider creativity around it. Anyway, I love that you used the word grace. That was like my word of the year. Picked it for 2021.
Yeah. I think it's a very good idea. We always need more you know, kindness towards ourselves, because we tend to be harder on ourselves. And I think that by exposing myself, by like saying like, here's my thing I made today, you know, like every single day, I've only been constantly reminded, though I still struggle with, you know, like that inner doubt, that I can get kind of reminded that it's actually, I'm doing pretty good, that actually a lot of people like my stuff, you know. So that's a nice check, you know. I can't be stuck in my head too much.
Yeah, that's so funny that every person has imposter syndrome that I talk, which is like
everyone we talk to. But also, it's important to remember that the voice that isn't kind to you in your head is usually not you. It's important to remember that.
Yeah, it is. Like, usually, you know, other voices you've heard, or maybe you have a chemical imbalance, or you know, who knows. I feel like my voice has usually been just like in combination of like experience of other people, you know, like saying, oh, you should do this, you should do that. Because like I said before, I've been always naturally talented at mathematics, and like, you know, then people are like, you're a genius and you should go and, you know, discover the cure for cancer or something, you know, like that. And it's always meant in good faith, but sometimes that becomes
it's a way,
so
people's expectation, of course. Tricky title to carry around on your shoulders. Genius, I think.
Yes, and it is usually the title I get. So, which is I am very fortunate, you know, that's the case. Like I admit that I am intelligent, you know, and that's great. But I think that also a lot of people don't understand different types of intelligences. So ultimately, I think that everybody is their own sort of genius in their sense. Like they have their own specific experiences, their own skills, and they can always grow in ways that they're weak. You know, I try to grow in ways that I'm weak. Like, I don't know, color theory is not really something I know. Like I said before, I just kind of let a simulation do the thing. So I try to learn about it, or I, you know, like other aspects of art or of you know, history. Like I'm horrible at history.
Oh, me too.
So
history and geography are not my strength.
Yeah, me too.
Yes.
I have to watch a movie because if I have to read it, I fall asleep like.
Yeah. So yeah, to Elithia's point, like every days are good, but they're not for everybody. And so any days, or I really like that concept because any day still includes every day, right? But you don't have to if you don't think it's healthy for you. So
yeah, it's up to how you feel. Like maybe you will have a period that you will do it daily, but maybe something happens in your life, actually not because of the art, like outside, that you can't focus, and that's okay. You don't have to stress because you drop it. So, and then you will come back at it.
And so there, like, I will allow myself to at some point not do one a day. You know, like there probably will be just like a singular day of sorts, and technically there was one day that I didn't post something, but that was because of like it was a social reason. It was part of last year on June 2nd, I think, or something. It was like the kind of blackout day. I still did a daily. I still committed it to my Git repo and everything.
But you didn't post it.
I didn't post it because, you know, that was like for other reasons. But still, like theoretically, I would let myself not do one. I think it's maybe unlikely because I like pushing myself really hard, you know. But I should at least have that mentality moving forward, because otherwise it's an unhealthy expectation, you know.
Totally.
Yeah, I have so much respect for people like you that can do, or what's her name, Saskia, I think, as well.
Also,
oh my God, she's been doing this as well daily for like many years, like you.
Beeple.
So, oh my God, all these people.
Beeple and Zach Lieberman were the main inspirations for me.
It's like,
I don't know if Zach does it daily anymore. I haven't really seen.
I don't know either. I don't follow him
he still
that
posts
closely.
them pretty often. I don't know if they're daily. Maybe not on Instagram, but I definitely see him posting pretty consistently on Twitter still.
Totally. Yeah. So it doesn't even really matter because he just posts amazing stuff all the time. So but yeah, that those two were the inspirations. Certainly Beeple for just the idea of an every day or daily, and then Zach Lieberman was the one who said, sometimes I spend 5 minutes, I literally just tweak like a number or something inside of what I did, and I was like, oh, I can do that, you know.
Yeah, pretty cool tip.
Sorry, go ahead.
No, I was gonna say if we have to leave because now it's 10 to
yeah,
exactly. So please tell us, like,
we'll have some sort of like concluding thoughts, and then I think we'll be good.
Yeah. Okay. Yeah, that's what I wanted then to suggest. Like maybe we give closure to this since we have like 10 minutes. But it's been great. Picking your brain. It's called in English.
It's so cool to see all your wizardry like live.
Yeah, and I'm glad that I could like help explain more aspects of ring marching, and give you at least a taste of some of the simpler, granted, but some of the iridescence you can get now with the dot products, with the the normal and the ray direction and all that kind of jazz.
Yeah,
I'm so excited to keep poking at it.
Yeah, me too. Because honestly, like some of these articles, like Amy Wong and this Michael, I've read them maybe 3, 4, 5 times, but sometimes still some like terms, I guess it wasn't like really, that sometimes you really need somebody else to explain it to you with those analogies or something, which I haven't found an article explaining ray marching that way, I guess. So, and also not in the extension that we did it today, because when I learned ray marching too with Charstell, which is a great teacher too, but there was not enough time for her, at least in the workshop that I took, to explain so much detail into every little thing, right? So now we went deeper, so which was very cool. So
definitely.
Yeah, I'm sure you'll have more people on who are ray marching experts, and you'll continue to delve even deeper and deeper. So I'm glad I could create a little bit of a groove, a little deeper groove for you guys. So.
Yeah, thank you. I am sure the viewers as well are super happy.
Yeah. And thanks, Mario, for all your participation.
Yeah, exactly. Yeah, thank you so much. And people will be able to watch the replay anyway.
Yeah, we're going to put up really fast. Yeah, I think. I'm definitely going to rewatch.
Yeah, me too. I was going to say to keep practicing. So Yeah.
Yeah.
So,
Cool.
yeah,
I'm
do you
gonna
have
check
any?
out my any day shaders after this for sure.
Yeah, come back. I'm picking it up just a couple of weeks ago, so I'm almost
Yeah, I've
daily.
been really enjoying it. So
Thank you. I was trying, and now I was like, okay, I'm actually understanding more ray marching. But now, after your session, wow, I already have ideas.
Looks awesome. There's like a little drop of water in the center. It feels like.
Yeah, yeah,
in
exactly.
our current daily, or
Your Aletheia's post, I think that she did.
oh yeah,
Just recently, yeah, I was playing with distortion, kind of like what you just show us, that you call it the cosine domain warp. But I would create instead like a variable called flow distortion, do the cosine sin in all of the positions, and then at the end where I had the shape, I would add the distortion to the shape. So it's pretty much the same. So it was interesting to explore that.
There's infinite possibilities of domain distortions and manipulations. Like, I recommend trying doing absolute values to create these like mirrors that go off in directions. And
I love to do that.
I'm definitely gonna do that.
This is kind of like what we did with Bruno's, you know, to fix this riddle. So that's why I like apps sometimes, because you can mirror stuff.
I'm definitely that person who, like, when I was a kid, I'd stand in the bathroom and like with the mirror. So I'm definitely gonna try that out.
Yeah,
I'm excited.
There's that reminds me, Eliza, that there's one of my friends, again, David Haskins. I mentioned him earlier about the whole like sky bringing down to the pictorial plane. I think you would especially like, he does these Mies corners, which is in reference to Mies, the architect who created like the idea of a glass skyscraper. So he had these corners on the edges that were like in a M, and my friend has been manipulating those and using those as ways of creating true mirrors, where it shows like what other people see, and it also follows you. So it's very much like what you're talking about, like going in the bathroom and having that corner, but it's like super trippy. Just
I
like
will be Googling that later.
Yeah,
so cool.
I'm not 100% sure how much he has online, but he has some at least. So
there's got to be something, at least one thing.
Yeah. I think I can even put into chat his Instagram. I do a lot of work with him. I'm basically his creative coder for his studio. So we've done lots of crazy projects, including lots of time mirrors, and you can see yourself in time. So go ahead and check out his Instagram. It does look like he has a Mies corner. Yeah, it's like number 5 or 6 on his feed. So
cool. Oh wow.
Oh cool. I love mirroring. Nice.
Awesome. Yay. Thank you for that.
Let's follow him.
Yeah, all this stuff is amazing. All the sculptural stuff he does are just so experiential. Like
nice photography too.
Yeah. Yeah, he definitely cares about how he takes his pictures and every aesthetic. He's a true artist.
Cool. So do you have last thoughts before you go?
Do you have any other like streams or anything coming up that you want to tell people
any
about?
resources that you want to give to people, or links from you, or?
Sure. Certainly my social media in general, which is all lejeunerenard, as my handle and Twitch is like. I will eventually be streaming myself. I've thought about doing like one night a week that I'll do my daily live. So we'll see. You
will be so excited about that.
Yeah. I think that for now, if you follow me on there or something, you'll get notified, depending on your settings. But like, I'll eventually do that if I get the guts to do it again.
You're basically the math teacher that I wish I had had. So I feel like you're going to be great.
Yeah. I think that I am more and more feeling like I need, and I told you about this, Eliza, but like I want to like educate people. I basically have deposited all this great information from people like Inigo and just like even from Jamie Wong's like articles, all these different things. I like to reiterate them and give them a new spin so that people can understand them in new ways, kind of like we did today. So
yeah, we'll be watching. So
definitely
we look forward.
Yeah.
Yep. So yeah, you can check me out on any of those, and I'll try to post things, especially on social, as I decide to do things. So that's at least a guarantee of where I'll talk about things. So.
Awesome.
Cool. So thank you everybody for being here with us today, for the ones that even stayed the whole time here.
Yeah, thank you for watching, everybody.
Yeah, thank you, 𝗶𝗀𝘀.
Yeah. Thank you, everybody.
Yeah.
Awesome.
Cool. Cool. Yeah, have a lovely weekend, everybody. Nice evening. Midday, and yeah.
Have a great weekend.
Yeah, see you in 2 weeks.
Bye, everybody.
Bye.
Bye.